He is Professor A.K. Gogoi. Professor A.K. Gogoi from IIT Guwahati from the Department of Triboli. Gogoi has been associated with many developmental activity as well as scientific activity and in the technological sense and development. And there is a small changes in our program schedule also. Professor Gogoi sir, that the first the speaker will join later in the maybe tomorrow session, and so the first speaker is Professor H. Bailong. I request Professor A.K. Gogoi sir to take over the charges. Thank you, sir.
Thank you, Dr. Phukan. Our session is the our third national conference on recent advances in science and technology. Today's morning, the first speaker is Professor Bailong. Professor H. Bailong is professor at IIST and currently they are holding the in charge post of the director of the institute. Professor Bailong is the plasma person. Okay, everybody knows him. I think we can start now. Professor Bailong, please continue.
Okay.
Thanks.
Yeah.
You will be talking about 35 minutes. 35 minutes is given. You can do a little bit here and there. Okay.
Okay, sir. Okay. Thank you. Whether my slide is visible?
Yeah. Slide is visible.
And my audio is also okay.
Yeah. It is audio.
Okay. Then let me start with thanking Professor Dhiraj Bora for organizing such a wonderful conference during this pandemic time and having so many speakers from around the globe. And personally, I thank the organizers also for inviting me to this conference. As introduced by the chairman, I'm H. Bailong from Institute of Advanced Study in Science and Technology. You have seen one logo that I have put having a 50 of Department of Science and Technology. Actually, this is the Golden Jubilee year of the Department of Science and Technology. ISST being under the umbrella of Department of Science and Technology. Happy to be associated with this department of its 50 years journey. But we have been under this department from 2009. And today I will be talking on little bit slightly away from plasma physics actually. Although the process is plasma research, but we have been stepping into a new application avenue of the plasma research. It is the nanomaterial synthesis by plasma process, and it is the plasma research in liquid. And normally people do experiment in gas phase, and we also synthesize some nanomaterial in gas phase also, which requires some vacuum systems to make the gas a little bit thinner. But this particular research, this particular area is in liquid. So we make a research, plasma research in liquid media, and try to synthesize some important nanomaterial. Since this is a kind of what to say, it is a kind of basic experiment kind of that we are stepping into. So we are very, very careful in going or the synthesizing the nanomaterial and the characterization. So I'll be more or less concentrating on the characterization part. What is the what we have characterized using the plasma research. So I'll be speaking on basically two systems. One is the tungsten trioxide. Tungsten oxide is a metal oxide, of course. You can see the synthesis of tungsten, that is WO3 minus X. The pure tungsten oxide is a semiconductor having WO3 notation, but we have WO3 minus X, means some of the oxygens are missing. So our aim will be to just to see what is the actual composition. That means what is the value of X. X of course is less than 1. So it will be somewhere in between 3, in between 2 and 3, of course. Then I will be giving you some insight about the experiment, then the characterization, compositional, morphological, and optical. And we'll see what is the advantage of this WO3 minus X in respect of its photocatalytic activity. I will also try to touch upon a kind of nanocomposite synthesis. It's a gold and copper oxide nanocomposite. It has a specialized application in biomedicine, actually the medical application of plasma. So I will touch upon very slightly on this particular synthesis. So this is the photograph shows you one very simple experiment that we designed. The reactor is a kind of, we designed the reactor here. It is cut out from a measuring cylinder, glass measuring cylinder, and we put 2 electrodes and make an electric discharge in between, putting a kind of DC voltage between 2 electrodes. You can see how the plasma looks like. And this is, of course, a kind of excitation, de-excitation mechanism associated with the ionization. So gives you the visible light photons, also UV photons. And the composition of the plasma, as you know all, that it is the electron and ions. But here, being a kind of inside a liquid, this plasma has a kind of variety of compositions, including hydrogen, then atomic oxygen, also the hydroxyl ions, hydroxyl radicals, you can say. And the physics is a little bit more complex here. Along with the gas discharge, it has a lot of thermodynamics because it heat up very strong, maybe large heat coming up in localized locations, as well as it has very, very active chemistry, which we will be utilizing in the synthesis of nanoparticles. And one important, because it is a kind of plasma, and yesterday we have very interesting talks by Professor Tripathi, then Manjit Kaur, also Professor Walsh, all about the plasma. But I would like to tell you, during this pandemic situation, I have come up with one analogy of the plasma behavior, which plasma people call as the collective behavior. Okay. So what I would like to say is that plasma has an inherent property of maintaining the social distancing. We plasma people call it a Debye length. That means the electron ions never come to a particular distance, closer than a particular distance, called Debye length. So social distancing is an inherent property of the plasma. That means electron ions do not come much closer than the Debye length. The other collective behavior is of course, it's an analogy, is that if something foreign body comes into the plasma, then the plasma has the plasma has the self-organized, self-designed property that it immediately make a containment zone around the foreign body. So that containment zone we call it a kind of device shielding. If any foreign body comes, then of course it sacrifices some of the electrons and ions. Some of its electrons and ions are lost over the body, but its property is such that it shields the influence of the foreign body so that it cannot infect the other parts of the system. So it is something like a kind of self-organized societal system. You can say plasma behaves as a self-organized societal system. So this is just one analogy, of course. And what the liquid plasma that we work on, is having, of course, electrons and ions, but we have specifically the reactive species, highly reactive, I can say, and the UV radiation. Of course, there are visible radiations also, but UV is more prominent, and the shock wave. And this liquid plasma, even you can say it is a kind of atmospheric pressure plasma because we don't use any vacuum system for it. And it has many applications. One we are trying to get into is the environmental. Environmental means to clean the air as well as the water. That is air cleaning as well as water cleaning. Material synthesis, which I will be talking here today. And also there are some biomedical applications we are stepping into we are just trying to see in the basic level what is the influence of the cold atmospheric pressure plasma on the, say, human proteins, like a standard protein like BSA, bovine serum albumin, as well as the some glycoproteins like hemoglobin and others. So we are stepping into all these three areas of the cold atmospheric pressure plasma, including liquid plasma research. Of course, the nanomaterial synthesis comes from the, we use metallic electrode to make the research from where the metal ions comes up. And of course, one can use metallic salts. We use, of course, metallic salts to make the nanomaterial. And the advantage is, of course, very simple reactor we use, no vacuum pump, and you can use pure metallic, nano composite, then metal oxide, alloys, any way you can manipulate. And they have very specific, you can tune their optical and electrical properties. And there is one important part is that photodynamical properties. I will come into at the end of this, by the end of the talk, what is the photodynamical property that we are looking into. So to tell about the tungsten oxide, of course you know it, it's a transition element. Tungsten oxide is a semiconductor having a band gap of 2.4 to 2.8. And the pure one is the stoichiometric, having abundance of tungsten valence state of 6+. It is an intrinsic semiconductor. And this substoichiometric one is the having abundance of valence state of 5+. Tungsten is an N-type semiconductor where this 5D conduction band is partially filled with the thermal electrons, which is coming up from the that is trapped in the oxygen vacancies, because it is oxidation, or the that is the coordination number is 5 here. And the oxygen vacancy behaves as a self-doping without introducing any impurities. And I will be utilizing it, or I will be looking at for the particularly the photocatalytic activity of this tungsten oxide. So this is a simple setup what I have used, the two tungsten electrodes, and in between I initiated research using a 1 kilovolt DC power supply. This is a laboratory make, and this is the reactor. I use deionized water, and putting up a kind of hole to take the water vapor get out, because it's a kind of very high heat generated here. This is a discharge characteristics. You can see you can measure the voltage around 1,000 volt very closely. So I use a 1000:1 voltage probe, high voltage probe, and a current probe to measure the current in this circuit. So the total power consumption is less than 100 watt. Maybe maximum is 250, then minimum is 50 watt. So in around 100 watt. And the electrode gap, of course, because the electrode get evaporated because the metal ions, tungsten atoms get evaporated from the electrode. So with time, the electrode gap increases due to evaporation of the metal. And of course, these metals are used for the oxide formation, metal oxide formation. Then just a schematic how the system goes on with time is the initial part is the anode and the cathode. Of course, the anode will get heated by the electrons, So all the atomic evaporation comes from the anode. And when I put up the electric field, that is the electric potential around 1 kilovolt, then this the shape of the pin, shape of the tip of the electrode is made in such a way that you have a highly localized electric field of around 200 kilovolt per centimeter. So this high electric field will generate a kind of will accelerate the free electrons towards it, make a channel here, evaporate the water in between the electrodes. This gap is less than maybe 2 millimeter. So evaporate the this will be a kind of water vapor in between, and the ionization process starts. So once the ionization starts, we have the ionization starts as well as the evaporation of the metal ions, tungsten atoms coming up. So they will interact with the hydroxyl ion or maybe this one metallic oxygen, atomic oxygen to get to form the tungsten oxide molecule. And with time, this tungsten oxide molecule will form nanoparticles, the bigger particles, I mean. So once the aggregation starts, they will form, they will make much bigger. Then, of course, this is a kind of continuous bombardment of by the energetic electrons at the field of 200 kilovolt per centimeter. So this in the process of aggregation, so there the defects comes up. That means the tungsten oxide is formed with at least some defects, means some of the oxygens are turned off from the decomposition. So when this becomes heavy, they settle down at the bottom of the reactor. So you can see the yellowish color of the powders at the bottom of the electrode slowly coming up. And the whole process in gas phase, we have the idea about less than a millisecond. But in liquid phase, we do the process up to 6-7 minutes. But the actual time frame at which the tungsten oxide grows up to few hundred nanometers, that we are not sure about, but it is still less than few milliseconds. And what is the aim of this is that experiment is to do the characterization and see the application potential of this plasma synthesized tungsten oxide nanoparticles. And what we do, we characterize them with for their optical, then compositional and morphological property, then the photodegradation. And while doing this, we compare them with two standards. One is the commercial bulk nanoparticles, commercial bulk tungsten trioxide. These are particles of not nano, but these are of particle 25 nanometer. And those are with a nanoparticle, they are of 100 nanometer. So these are commercially available from chemical suppliers. Of course, it's branded by Sigma Elric. So the tungsten plasma synthesized tungsten oxide will be compared with two standards. Starting with the optical property, you can see this is the DRS spectra by UV visible, the first available one. You can see the commercially available, one is the bulk, the other is the nano, having an absorption peak of UV around 300 nanometer and no absorption in the visible part. But what is showing by our plasma synthesized one, having a shift towards the lower nanometer, lower wavelength peak at the UV, but you can see there is a kind of tail in the visible region. So we have an absorption in the visible region. This indicates that we have synthesized the synthesized tungsten oxide has the abundance of the valence state of 5+ of the tungsten, because this has a broad absorption in visible region. So this is the first indication. The second is the band gap. You can determine, because this is the DRS spectra. So from where you can determine the band gap. For the bulk and commercially available one, the band gap is 2.54, 2.56. This you can measure from here, from this curve. And the plasma synthesized one is showing a band gap of 2.15. So it is a kind of band gap tuning. You can, the plasma synthesized one, with plasma, we can tune the band gap. So, but then the compositional part, we use the X-ray diffraction. This is the international standard, Joint Committee for Powder Dispersion Spectra. This is the standard data, and coming up with the two standards: bulk 25 micron tungsten oxide, then the nano 100 nanometer, and the plasma synthesized. You can see the plasma synthesized one has the almost similar characteristics. That means we are in the we are sure that it is tungsten oxide. But there are few kind of informations. Information means deformations, you can say, that these particular planes are deformed. The XRD planes, XRD data shows that these two particular 022 and 0202, these two planes are bit deformed. So this is one indication that we are still, we are sure that we are producing tungsten oxide, but having some kind of deformation in the crystal planes. This is the Raman spectroscopy, bit more powerful technique to see what is happening in the crystal planes of the plasma synthesized one, comparing with the bulk and the nano, two standards. The first one is this is the Raman shift measured in centimeter inverse. From 70 to 100, this part represents the lattice vibration. We have seen a clear peak at 90 centimeter inverse. This gives a kind of indication that the lattice vibration is having a kind of modification. And two important modifications come up. One is the tungsten, oxygen tungsten. This is the bending mode. Yes, this is the bending mode. And where you can see there's a shift in the peak position as well as the broadness. Similarly, in the stressing mode, the tungsten, oxygen, tungsten, the stressing modes, if I enlarge, you can see the broadening as well as shifting. So this is the another confirmation, confirmatory note that we have the broadening gives you some kind of information about the presence of amorphous layer. That means some of the missing oxygen atoms will give you some amorphous layer that will broaden the peak, Raman peak, as well as the shifting of the peak towards the left. So these two gives us some indication, not some indication, but a bit clear indication that the oxygen atoms in the lattice is some of the oxygen atoms are missing. We do another powerful analytical investigation using X-ray photoelectron spectroscopy. And this is the survey. Of course, X-ray photoelectron spectroscopy gives you all the information about the element as well as the chemical states. So for a typical example, we are considering the tungsten 4F state. So this particular peak is analyzed here with deconvolution to see what is the abundance of the valence state of tungsten. You can see the blue and the green is having tungsten 5 plus 4F 7/2 as well as 4F 5/2. So the abundance is much larger than the tungsten 6 plus. Tungsten 6 plus is these two. So calculating the area under the curve, you can compare, we can measure that what is the abundance of W5 state as well as W6 state. So what we have found is that W5 species, 5 plus species, is 45% more than the W6 states. This gives another confirmation that we have the oxygen defect states, means there are many places where oxygens are not present. So this is the kind of representation that the oxygen that is tungsten octahedral structure, one oxygen is missing from there. For the morphological analysis, we do TAM. As I told you, we are very, very careful on getting all the information clear on this plasma synthesized tungsten oxide. So this picture, TAM photograph, micrograph, you can find anywhere in the Google that this looks like similar. Of course, not different from regular tungsten oxide, but it has a little bit irregularity in shape, polycrystalline in nature. And what the EDX, energy dispersive X-ray analysis, can give you, can give us the elemental composition of oxygen and tungsten. So this gives us that atomic ratio of tungsten to oxygen is 1:2.4. That means in normal pure form, it is 1:3, WO3. So now it has come up that it has a kind of 1:2.4. That means those 3 minus X, X is having a kind of value of nearly 0.6. So our synthesized tungsten oxide is coming up WO 2.4, something like that. And then, of course, you can see where the oxygen atoms are missing in the crystal plane. This is the high resolution TAM. You can see the lattice spacing. You can measure the lattice spacing. You can see what is happening here at 2 different locations. We have seen that the lattice crystal planes are discontinuity there. So showing the vacancies. So this is the defect sets, you can say, where the oxygens are not there and the electrons are tapped there. So to see the photocatalytic activity, that is how the photocatalytic activities are, what is the standard of the plasma synthesized nanoparticles. And this is a kind of standard. We call it a methylene blue. It is a organic dye. It is a very stable organic dye. And it is used as a standard for to quantify the activity of the catalyst. So what we do, we mix equal amount of commercially available 2 standards as well as the plasma synthesized one, and see the degradation. So the degradation process, of course, well known how the photocatalytic agents can degrade the organic dyes. So the performance is, you can see that is the commercial bulk. Commercial bulk is this one, green. Then the commercial nano. These are 100 nanometer commercial nanoparticles. Commercial bulk is having 50% degradation. Commercial nanoparticles having 62% degradation. Of course, we use a solar simulator. And the plasma synthesized one can give you the highest, maybe 77% degradation of the this dye. So it is more effective because it has a kind of oxygen vacancy, and this oxygen vacancy traps electrons over there. And these electrons are used up in the process of photocatalysis. So this is the mechanism that we propose, in fact, for the degradation efficiency. And to summarize this part is that we have, okay, this is the in this particular schematic diagram, we have shown that we have reduced by the oxygen vacancy, creating the oxygen vacancy. What we have seen is that the oxygen vacancies are the locations where electrons are trapped, and these electrons, trapped electrons, make the band gap a little bit smaller, so reduce the band gap. And this narrow band gap that we have calculated is that 2.15 eV. This narrow band gap tungsten oxide nanoparticle we have synthesized in liquid plasma and show higher photocatalytic activity. And this is, of course, come up in very recently in plasma chemistry and plasma processing. In March, this has come up as a full paper, and this is kind of like a book chapter. This is a full paper with all complete analysis. It is a 18 journal page. This is a full paper, I can say, 18 journal page. Anybody interested can look into this paper for all details. The next system I would like to talk upon is the nanocomposite of gold and copper oxide. Why we are taking this particular system, I will tell you in the coming slides. The copper oxide you can use. I use the same way, means 2 copper electrodes. It is the same process by which copper oxide is formed. But what additionally we do it here is that we use a kind of a metallic salt, a salt containing metallic ions. It is not written here. Maybe it is actually hydrochloroauric acid, HAuCl4. So this metal is the gold chloride. We mix it with water, then get that solution, or to get that liquid, and put the system of the copper electrode system. That is, we made the discharge not purely in water, but with the metal ionic salts. So the mechanism. This is the solution in which the discharge is made. Is HAuCl4, hydrochloroauric acid. At a different molar concentration, we use 0.1 to 1. And this is the color. You can see it is the copper, so the green color is coming up. And this is the chemistry in between the electrodes happening during the discharge. We have copper atoms coming up. Then the oxygen, atomic oxygens are there. Hydroxyl ions are the hydrogen ions. Electrons, of course, are there, and of course the hydroxyl ions, because it is a kind of water solution with the salt with the molar concentration, millimolar concentration of 0.1, 0.5, and 1. So again, coming up with the because this one similar to the tungsten oxide, we produce the copper oxide first without putting the particular solution. If I do it in water, then I will get copper oxide simply. Then if I use the gold chloride solution over here, then of course the copper oxide nanoparticles will be decorated with the gold nanoparticles. They will not coming into the crystal structure of the copper oxide, but they will be decorating the copper oxide at the surface. So gold nanoparticles will be sitting or will be bonding to the surface of the copper oxide nanoparticles. So this is a work that is of importance in biomedicine. So immediately with X-ray depiction, we see what is happening to the addition of the gold. So this is copper oxide. You can see this copper oxide, the plain one, we produce in the plasma research. Then you can see with addition of gold, you see how the structural modification is coming up. At the end, this is the 1 millimolar copper solution. So you can see this these two planes. Out of these 2 planes, 1 plane is missing almost, and this plane is going up. Then then we have few new planes coming up, which are not almost visible in the pure copper oxide form. Then when the gold is incorporated, we have clear indication of some new planes. So these are the contributions of the gold, of course. This is the from the gold coming up. This is also from the gold coming up, and this one is also from the gold. To see the structural, that is the morphology, Without gold incorporation, this is the structure. We call it a nanospindle. And of course, nanoparticles have a different absorption, UV absorption, or you can say optical property when their shape is different. So copper oxide nanospindles we produce almost all the time. I don't know what is the reason, but there must be some reason that is a gold pattern is nanospindle. And with incorporation of the gold into the system, the growth pattern is changed. So what I can say that the nanospindle structure is become little bit kind of seed-like structure, and this is one example showing that in the nanospindle, copper oxide nanospindle, gold nanoparticles are incorporated. So these are the gold nanoparticles sitting over the copper oxide these nanospindles. So this is the HRTM images showing the lattice plans. So this is, of course, here you can see clearly, more clearly, that how the growth pattern is changed. Now they are not almost a spindle like a seed, coming up like a seed. So this reason why the growth pattern is changing, we are looking into it, because this is until now this is not published one. This is very recent work, and I can show you the structure or the surface of the copper oxide. These are of course the gold nanoparticles, and the structure is showing some porosity in its surface. So this is also one important important what you can say important structure so far as the photocatalytic activity is concerned. And finally, this is the optical property that we are looking for in a copper oxide and gold nano composite system. Normally, the purest form or maybe spherical form of copper oxide will give you an absorption at around 300 nanometer in the UV range, and there is no absorption in the visible range. What we have found is that because of the spindle shape, copper oxide has a very, very large kind of absorption tail in the visible range up to the maybe near infrared. What is more interesting is that when I incorporated gold, this absorption in the visible to the infrared increases. So this can be of course useful in the case of sensors also. And going on more gold incorporation, you can see the absorption in the entire visible range as well as extended to the IR region. What is more interesting coming up when we have a gold incorporation little more 1 millimolar. These are the millimolar concentration of the gold solution. So you can see a kind of clear peak here. This clear peak is the signature of the plasmonic peak of gold. So gold plasmonic peak has a kind of around 530 to 40. So we have got it around 550. And to tell you the truth, we are trying to shift this peak, plasmonic peak, towards the near infrared. And we have been successful. Maybe we are at the 650 around at present. We are shifting this peak. We are able to shift the peak up to 650, and we are trying a little bit more towards the IR region. So the reason why we are looking at the shifting of the plasmonic peak towards the IR is that this particular kind of system people are trying to use for its photodynamical therapeutic application. Photodynamical therapeutic application is something like that. You use a kind of say if this peak is in IR, so you use one IR laser, put the nanoparticle in a particular say cancerous cell, and use IR laser to excite this nanoparticle to generate a local thermal effect. So very strong heat thermal effect will be generated locally at the location of the cancerous cell, and so that it can damage the or it can kill the cancerous cell. So that is the idea behind the photodynamical therapy for the cancer treatment. So we are looking at such a system for making the plasmonic peak towards the IR. So we are in the NIR, you can say, because we are in the 650 at present. So in summary, what I can tell you is that we have synthesized both the copper oxide as well as tungsten oxide in in liquid plasma system. It is a inbuilt and indigenous plasma reactor. Even the I can tell you that the plasma discharge power supplies are inbuilt in our laboratory. Of course, we buy the transformers and other things. And these are showing very good promising area as a very promising area in application, and not only in the photocatalytic activity as well as also in the photodynamical therapeutic application in biomedical science. So these are some references that I have used in preparing this slide as well as doing my research here. And thank you for your kind attention. So I end here.
Thank you, Professor Bailong.
Yes, sir.
Any queries now?
Okay. Okay, I'll be happy to reply, of course.
Hello.
Yes.
Yes,
Yeah.
sir. Thank you very much for the talk. Now I handed over to Professor A.K. Gogoi, sir, to ask the questions. Already we have many questions. Sir, can you see the questions?
For me, of course, I cannot see.
No, sir. Gogoi, sir. Gogoi, sir,
Okay,
can see the questions?
No questions. I don't see the question section.
Okay, then
I
I will
have
read
on
the
that.
question.
I don't have any questions.
Okay, sir. Then I will read the question. First question, respected Bailung, sir.
Mhm.
To what extent the dye degradation
Mhm.
and pollutants decomposition is expected by your nanocomposite material? If it is successful, then what would it be your opinion to prefer dye degradation with your nanoparticle instead of using biomass by other researchers?
Okay. To tell you the truth, as I told you, we are just stepping into this field, and we are showing that this particular structural change in the say tungsten oxide nanoparticles can give you a better photocatalytic activity. We are not searching, we are not looking at for the commercialization or maybe any other aspects of utilizing it in commercially. But what is the to what extent we are expecting the degradation is that what is expected is about 80%. We have gone up to 77%. Is expected up to 80%, and what we are looking at is that if we can reduce the time, because we are doing all these things in a solar simulator, because the normal utility or normal application in the field will be based on the natural solar light that must be having some kind of UV as well as, of course, the sufficient UV component as well as the visible. So the tungsten oxide plasma synthesized one is having a little bit tail in the absorption of the visible region, in the visible region. That is the reason that it shows little bit more effective. But still there is a issue that it is taking little bit more time. More time means I am showing you the data. I have shown you the data of the 200 minutes. 200 minutes means it's a little bit more than 3 hours. So I don't like that. I don't think that this is will be more commercially viable. So to me, its time should be little bit lesser. But the prospect is that the process by which we produce the nanoparticle is very small time, within very small time. That means my production process takes only 5 minutes. I don't use any toxic reducing agents, no acid, nothing, no other chemical. That is the feasibility.
Okay, thank you, sir.
Yeah.
So next question asked by another participant. Good morning, sir. Nice work. I am curious about the calculation of discharge length, and does seat play a role here?
No, these are discharge length is something different because to maintain the discharge, if I have a particular power supply with say 1 kilovolt, then you need a kind of particular discharge length. So if I want to make it a kind of little bit say a little bit longer discharge length, then I have to use a kind of little bit more discharge voltage. So the reason, because if you maintain a discharge gap of little bit larger, then you need a little bit more discharge voltage, of course. This is a kind of optimized kind of thing. And since yeah. So the seat part is, of course, one has to look into it, because at present, because the structure of the seat, the dimension of the seat, these things we are handicapped because it is inside water. Only thing is that I can measure the plasma parameters, density and temperature by optical emission spectroscopy. I have not shown it here. But we use a kind of optical OES system to measure the to get the hydrogen alpha line, to get the temperature and density calculation. That's all.
Okay, thank you, sir. So another comment, it is clear explanation, sir. I liked it. Okay. Then next question by another participant. Sir, it is a very nice presentation, very informative. Thank you. Oh, sorry, no, it is not a question. It is another comment. Then another one, dear sir, it is a nice talk. I have a query. You said about the Dubai, I think it is a land, not island. You
By
said
length,
about
yeah.
the Debye length, sorry,
Yes.
length, while using the plasma.
Mhm.
So my question is, if a external stimuli is applied for tuning the band gap, all the charge carriers will form some island rather than get separated. So how could we find the enhancement of prominent characteristics?
Okay, to tell you about the Debye length is a kind of is a characteristics of plasma. Uh, Characteristic scale length of plasma, you can say, is a characteristic scale length of plasma. It is characterized by the density as well as temperature of the plasma component. And the other part is that you can say, of course, you know that plasma has a variety of wide range of parameters. Plasma parameters has a very wide range. Yesterday, Professor Tripathi has shown you, starting from ionospheric plasma to the core of the sun, or the surface of the sun, you have a kind of density difference as well as temperature difference of 10 to the power maybe around 20. So, but still, the Debye length is the one special characteristics of the plasma at all levels. Of course, the length is different for different plasma, but the length is a kind of characteristic length of the plasma. So this in the case of liquid plasma, liquid plasma is a kind of is a very complex kind of plasma. Of course, most of the laboratory plasma has neutrals over there, but most of the neutrals are of same kind. But here there are many neutrals which are of very different kind. And here we have very different chemically active species like the hydroxyl ions, hydroxyl group OH. And to be specific to your question, how you can tune the property, for this actually we have measured the OH concentration, hydroxyl ion concentration. So this hydroxyl ion, and the abundance of hydroxyl ion or the production of hydroxyl ion in the system actually takes a kind of very critical role. So if you go through my paper in plasma chemistry and plasma processing, you will see how we have measured the hydroxyl ions over there. This is one critical parameter that I can tell you that takes care of tuning the lattice structure, you can say.
Okay.
Tuning the energy gap.
Yeah. So the last question is,
Yeah.
last question is, metal oxide are crystalline in nature,
Yes.
and therefore, have you applied your nanocomposite oxide in recent advances in material science?
Okay, this is a kind of generalized question, but okay, this whole approach is a kind of the whole approach is a kind of towards the advancement of the material science. The whole advancement, the whole process is towards the advancement of material science. What I can tell you.
Thank you,
You
sir.
can- yeah.
So, sorry, I missed one question.
Yeah.
Sir, what is the role of oxygen vacancies
Yeah.
in optical and magnetic properties of tungsten oxide?
Yeah, oxygen vacancy is actually, yeah, this is a good question. In fact, the oxygen vacancies are the locations where the electrons are trapped. In fact, so to get the charge balance, so the electrons are trapped, and these electrons are utilized by the because these electrons are excited because these electrons are available there, no? The trapped electrons are available there, and by they are thermally they are due to their thermal motion or the thermal due to their thermal property. So these electrons can move to the conduction band. They can partially fill the conduction band, so that normally say tungsten oxide trioxide in the purest form is intrinsic. There is the 5D level of the conduction band is not there is no electron in the 5D conduction band. 5D level of the conduction band, there is no electron. But when they are trapped here, due to the thermal motion, they can partially fill the conduction band. So what is this is the reason behind that we get a kind of the band gap little bit shorter. So this is the what we speculate is the science behind that, why the reason why the this one. Is it not only the science behind the reduction in the optical band gap.
Okay, thank you very much, sir, for response of all questions. Now, I just request to our Professor A.K. Gogoi sir to declare the next speaker. But already Bipin Kumar Jadhav sir is available with us. So sir, can I ask, are you ready to present your talk?
Yeah, I'm ready. Can you hear me?
Yeah, we can hear.
Yeah,
Sir,
yes, yeah.
okay, thank you. Sir, Professor A.K. Gogoi sir.
Yeah. Please, acha. Okay,
Yes, sir.
okay.
Then you can start
And
with Bipin Kumar Jadhav sir.
okay, thank you very much. Thank you.
Yeah.
So I think we have to say a very thank you, Professor Bailong. People have shown a lot of interest. It's a wonderful talk. Okay? I think we now move to the next talk. Next talk is invited talk by Dr. Bipin Kumar Yadav. He will be talking on magnetic field measurement at first Lagrangian point. Dr. Jadhav is presently working as a principal investigator of the FluxJet magnetometer on Mar Aditya L1 solar mission. He has quite a lot of large number of scientific papers, 45 scientific publications, and his special interest in the plasma parameters and magnetic and electric fields in the space regions. He was payloads and joint project. And during his tenure at Calcutta, he developed a fully equipped X-ray testing laboratory. I think now, then he was working on the Mars exposure neutral composition analyzer also, and atmospheric composition explorer on board Chandrayaan-2, and also he is an moon-bound hypersensitive atmospheric Langer probe design is one of the key designers, Rowan Vikram later, and plasma analyzer package for Aditya. So a very active, practical person, I believe, Dr. Jadhav. We welcome you, and he is also actually did PhD under supervision of our present ASTU Vice Chancellor, Professor Bora. I welcome Mr. Yadav to please kindly deliver your talk.
Thank you, Professor Gogoi. That was a nice introduction. So I'll
Yes, please.
yeah, sure. How to share the screen?
I guess you can check in the bottom of our screen. There's a share screen option.
Yeah. Can you see my presentation now?
Yeah. It's there. Magnetic field
Okay.
measurement at first Lagrangian.
Yeah, yes. So thank you all for giving me this opportunity. Actually, I'm sorry for the shift in this presentation, because yesterday suddenly a meeting came up and I have to make two presentations regarding the upcoming missions. So my apologies, sincere apologies for that, and thank you for accommodating me today for that. Actually, today also the meeting is going on. I have just taken a break for this presentation. So what I'll be doing is that I'll just touch upon the subject on magnetic field measurements that we are going to do. I'll just show that. So right now I'm working on this the Fluxgate magnetometer, which is there on board Aditya L1, which is the first actually solar mission of India. And the same thing we are going to do in our Venus orbiter also, which is now in the pipeline. I mean, it has not been approved, but it is with Government of India right now. So there is a payload called Viper, which is Venus Ionospheric Plasma Wave Analyzer. And the magnetometer is also a part of that. And of course, Padma, which is plasma wave analyzer for Mars. That will be on the second Mars mission, which is also in these all are future missions. Right now, Aditya L1 is there, which is scheduled to launch next year. So with this, I will just start it. This is the solar interior we all know, from where this magnetic field and all things start. So you can see the plasma parameters over here. I do not know how to use this. So the density in the core is something like 10 to the power 26. For photospheres, it drops down. Okay, and magnetic field in the core, since the particles are very very tightly bound over there, so the magnetic field does not exist. But when we come to the photosphere, the charged particles starts moving, and the magnetic field starts coming into existence, and the values I have shown over here in this. So basically, I do not know this how to. I'm not able to use this pointer somehow. I don't know if someone can tell me.
So yesterday I was able to just right click my mouse button, and then there's an option for pointer that you can select laser pointer if you right click, but that was Windows computer.
This is actually Mac, so I'm not very comfortable with this. My sister gifted it to me, so I have little this thing. I do not know how to. Some half screen is coming over here, which I'm not able to. So I'm not able to see my full screen actually. So maybe now it is okay. Yes. So yeah, now it is okay. So these are the numbers, and then when we reach up to Corona, the magnetic field is again 0.10 Tesla, which is something like 1 Tesla is 10 to the power 4 Gauss, we all know. So basically the sunspots are a temporary phenomena which takes place on the photosphere, and in the left, the figure down, if you see, these are the magnetic field lines which are coming from the surface and then going back. So since light is not coming from that area, so this area appears to be dark on the surface. But actually it is an intense magnetic field region. And if you see the actual picture of this, you can see over here. So there's a big magnetic loop which is taken by extreme ultraviolet by TRACE satellite, and you can see there is a big loop which is coming all the from one side of the surface. And of course we know that magnetic monopoles cannot exist, so the magnetic field has to close down, and on the other side it will close down. So the idea is that I'm showing these slides just to give an idea that sun is a big source of magnetic field which is coming along with the solar wind when this radiation and field and these particles are coming out from the sun. So basically three things are coming out. One is the radiation, all the way from your radio waves to the X-ray and all, plus magnetic field is coming, electric field is coming, and of course particles are coming in the form of solar wind. So these all three things comes, and this is just a part, I mean, from where this field actually originates. That's what I want to show over here. So this again, I continue with the sunspots. You can see over here on the left-hand side. And then if in a more closer view, if you see the granules and the black patch which is there, which is nothing but basically the footprint of the very strong, intense magnetic field on the surface. And the same thing is enlarged on the extreme right picture over here. And this is, as I told earlier, the dark spots. The normal temperature of photosphere is around 700 Kelvin, but when the magnetic field drops down, it becomes almost like 3700. So almost 2000 degree Kelvin drop is there, and that is why this area appears to be black. Now these sunspots can last for several days, and in fact they can last for a few bigger ones. They can last for several weeks also. And this is how basically this interplanetary magnetic field that we call, which is basically the magnetic field which is coming out of the sun. And we know things are not coming out just in the radial direction over here. You can see a spiral kind of a thing over there, which is nothing we call as the Parker's spiral. And when the particles are coming out, they just do not come out in the straight line. They follow the field lines, which are basically circular in nature rather than this is coming straight. And this is because of the radial outflow. You see, because the sun is rotating very fast. So because of the rotation and frozen in flux concept, these things are coming out in a spiral kind of a thing. And you can see that green part over there, which is the sector boundaries, which corresponds to the passage through the heliospheric current sheet that we call, which is generation of all these activities which is happening. Now, two components are there of this magnetic field. One is the radial component, which varies as r⁻⁵. It was earlier thought that this is 3/2, but then experimental observation showed that it's not -3/2, but it is actually 5/3. And then the transverse magnetic field, which is there, varies as 1/r. So in total, if you see, because we know magnetic field is a vector quantity, so we cannot just add them like that. It has to be added in a vectorial fashion. So the actual magnetic field, if you see, that comes out varies as r⁻⁻⁴. That means inverse of r⁻⁴, 1.4. So these are the average parameters at one astronomical unit. You see, the solar wind, typical solar wind is 450 kilometers, but it can increase in the case of extreme transient solar events, such as the coronal mass ejection. I have not taken into that thing over here because then it will go in a different mode. So, but it can go up to 2000 kilometers per second when a CME occurs. CME is a coronal mass ejection, which means the sun throws out a lot of matter from its towards the interplanetary space. And in that case, what happens is the normal particle density, which is like 7 per centimeter cube, can go up to 10, 20, or even 50. And the magnetic field also, which is typically now shown over here, 5 nanotesla, can actually go 10 to 20 times of it. It can go up to 50, 100, or even more than that. And of course, the temperature also, which means the average velocity of the particles that are coming, that also increases. So the number density increases, the magnetic field intensity increases, and the particle velocity. So all these things basically increases when there is a solar transient event. And Olfin waves are also, we know Olfin waves, basically, this is nothing but a magnetic disturbance. And this magnetic disturbance, when it propagates through the medium, it basically picks up ions from the plasma that is surrounding it. And these ions are basically stuck in a way with the field lines in such a way so that when the magnetic field, the velocity is increasing, the magnetic field also, the magnetic field is increasing, the velocity also increases. And when the magnetic field goes down, the velocity also goes down. So both the magnetic field and the particle, they go hand in hand, as if the particles are stuck to the field lines. So this Olfin wave is also coming along with the solar wind with a velocity of something like 40 kilometers per second, but then it keeps changing also. In case of events, it can even go higher. The energy can also go higher. And in a way, it can basically vary the magnetic, and temporarily, it can vary the magnetic field around a particular region. And this is how, this pictorially, we see how the plasma is there and how the things are coming out of the sun. And this is how the IMF, interplanetary magnetic field, that I'm telling, how these measurements are taken. Of course, very near to sun, we don't have any measurements, simply because the conditions are very hostile over there. We cannot put anything to measure in situ measurements. However, with remote sensing techniques and by taking the temperature ratio, we have observed a few of the magnetic fields which are shown in this plot. You can see along the Parker spiral with the radial expressions, and observations, of course, with the thick line you can see over here. And this is the distance is measured in 1 AU. So you can see we have measurement all up to 4.5. But now I think that one solar probe has gone, and I think it is going very near to the sun. And of course, I think we'll get some points near the 0 part region also now onwards. So with this introduction now, I'll go. This is the Lagrangian point. I'm sure most of the people are aware of it, but still I will tell. Actually, if you take the Sun-Earth system, Okay, it's a two-body problem. Now, if you introduce another body in between somewhere, so it will become a three-body problem. And if you solve the equations for basically gravitational equations for this three-body problem, and in a plane, of course, in this plane, you will get 5 roots. And these 5 Lagrangian points that we called, it was done by Lagrange, so they're called Lagrangian points. These roots, if you plot in this plane, you will get like this, the L1, which is actually on the line which is joining the solar center with the Earth center, and it is like 1% of the Sun-Earth distance towards the Sun from the Earth. And at this point, virtually the gravity of the Sun and the Earth, they matches. So if you put anything around on that point, it will move around on this line around the Sun like the Earth is moving. So the advantage of this point is that if you put something on this point and points towards the Sun, you will be looking all along without any hindrance. You will be looking Sun all the time, despite Earth is moving or despite the movement of the Earth. Now, exactly on the opposite side, you will have L2, which is in the shadow of Earth, and it is away from the Earth side over here. Similarly, there is another one on the path which the Earth takes moving around the Sun, which is L3, which is on the opposite side of Sun. And then, of course, you have L4 and L5, which is all on a 60-degree angle from the Sun-Earth line. And the L4 and the L5 are the most stable point. The L1 is not so stable simply because of the reason that the distance of Sun and Earth is not constant, and it changes with time. So this is also not a fixed point. Basically, it also moves. So if you put a satellite on this L1 point, either it has to move perpendicular to the Sun-Earth line, or it has to move in a circle looking at the Sun all the time. So, but the advantage is that anything solar wind or anything which is reaching over here, it reaches almost like 1 hour before it reaches to Earth. So in case we put a probe over there, and if we know that there is some solar magnetic storm is coming, which is not a very good thing for our power lines as well as for the satellites, which is moving around the Sun, we have some precautionary measures we can take, and we can maybe switch off the satellites or some part of it, because it can disturb. And we know that Quebec, one incident has happened in Canada when the power lines were snapped because of the extreme activity of the Sun, and even the Earth's magnetic field was not able to basically shield those highly energetic particles which came and fall on the power lines, and the power lines were snapped. So this is the configuration. Now we are sending a mission to L1 point. I'll come to that thing later. But before that, going to that, what are the significance, or why we should measure magnetic field at L1 point? The simple thing is that the continuous measurement of magnetic field, in this basically we know away from the Earth's magnetosphere how the magnetic environment is there. Second thing is that the magnetic field measurements gives, basically we can interpret the charge particle distribution both of the thermal and of the energetic and their source location, simply because, as we know, that frozen in field concept, the charge particles follow the magnetic field lines when they are coming from the Sun towards the Earth, or going towards, I mean, we can measure for towards the Earth because they are coming to, and we have measurements, but they are going in all directions. But those which are coming towards Earth, definitely we can have a measurement, and magnetic field is an integral part because the charge particles follow the field lines. And then we, of course, to understand the static and dynamics properties of the solar wind itself and its influence of the near Earth space weather. Space weather is the plasma environment around the Earth, plasma and magnetic field environment around the Earth, and how it is changing. So those things we need to know what is happening outside our Earth's magnetosphere, because it has a direct implication of what we are doing. I mean, societal application, it can disturb the normal life on Earth in case of extreme events. And of course, it can help the study in dynamic phenomena such as hydromagnetic discontinuities and solar plasma waves. I'll coming to this last topic, which is my pet topic, a little bit later on. So how do we measure this magnetic field that we are talking about? Now, we basically use a instrument which is called a magnetometer. Now, we know that Gauss meter is there, we can measure magnetic field. But if we have to measure a very low intensity feeble magnetic field in terms of nanoteslas, then we employ an instrument which is called magnetometer. And it is important because it measures basically magnetic field everywhere where we can explore, because even if there is any planetary mission that is there, magnetometer is an integral part of that, because the magnetic field is an intrinsic part of any planets. We know that Mars and Venus are two planets in our solar system which are deprived of this global magnetic field which is there on Earth, on Jupiter, Saturn, and the Jovian planets. And of course, Mercury is also, but Venus and Mars, the two neighbors on either side of Earth, do not have, which is a very interesting factor in itself. Then it can provide information regarding the physical processes which are taking place in the remote locations, such as the interior of bodies, which is otherwise inaccessible, I told you earlier. And there are magnetometer surveys which are done on Earth also, basically under the water or sea, and everywhere it is used for various applications. I have that slide I have removed because of the scarcity of time. And it all started initially, there were digital and basically the readings were copied down manually. In 1950, then the quantitative measurements started. Long-term variations of Earth's magnetic we start noting down those things. Finally, strip recorders were invented, and you can see here some of the primitive magnetometers that were used on there. And in our Indian Institute of Geomagnetism is there. They have a very good laboratory in Alibag. I visited that a few years back, and they have very nice old instruments which were used or basically employed to measure the magnetic field. Earlier that observatory was in Kolaba, but since the urbanization of that Mumbai area, it was shifted to Alibag, away from the power lines and all the things which can disturbance the measurements of Earth's magnetic field and its day-to-day variations. And these are the plots you can see on a quiet day on the top. And of course, when there is a disturbance, how it looks like, you can see that the fluctuations are there in the magnetic field. Then there are three types of magnetometers. I'll not go into details. The helium vapor, proton precision, alkali vapor. These all the information is available on the net, and one can just search and then go through that thing. And there are two vector, basically they only give you the magnitude of the magnetic field, but the vector magnetometers, the flux gate and the search coil, they give you the magnetic field as well as the directions. So you know that PVX, BY, BZ, which direction the magnetic field is more and which direction it is less. So which magnetometer to use if you have if you just see the frequency versus the minimum detectable amplitude from 0.01 to some 1000 hertz. If you see, you can see the region, and 1 gamma basically is nothing but 1 nanotesla, as we say. So at higher frequencies, we use a search coil magnetometer, which is just nothing but a pickup coil. You have a coil, and you know when the flux changes over there, an EMF got generated, which is taken up in the form of voltage signal, and we can plot it with variation with time, how the flux is changing with time. But the flux gate magnetometer basically gives you the steady state magnetic field. Okay, so the flux gate magnetometer, this is the detail. I mean, I'm not going to the detail. The 3 windings are there for 3 particular axes, and the AC drive, basically what happens is you put the sensor in that. There are 2 coils basically, the excitation coil and the sensing coil. I think in this we can see, yeah. So one sensing. So what happens is that you put that sensor and put so much current in the excitation coil that it becomes saturated. Now, when it becomes saturated, the core becomes just like a paper, and the magnetic field start passing through that one. And then when it is put in an external magnetic field, the imbalance basically drives the core from the saturated part to the unsaturated part, and the difference you put extra current to make it saturated again basically is proportional to the external magnetic field. That is how the principle it is there, and that's what I've written over here. The details I'll not go because. And this was the earlier magnetometers which were sent on spacecraft. You can see over here that red circle basically is the magnetometer coil over here, and this is the Sputnik, and you can see the driving motors and gears, how it was rotated. Single coil was there, and it was rotated in 3 different directions to get the 3 different vectors. So, and as I told earlier, magnetometers, I mean, it is a integral part of any mission, starting from Sputnik in 1958 to all the way up to the latest 68 and beyond, and now also it is there. So there is nothing great. I mean, as such, magnetometers are. So what is so special? I mean, so India is also sending these fluxgate magnetometers on board or satellites, but they are primarily sent as an attitude control. I mean, we need to know the direction of the satellite. So we are sending these magnetometers as an directional, I mean, sensor. But in Aditya L1, we are sending a magnetometer as a scientific payload for the first time. So that is what we are starting. Now, there are a lot of, I mean, we can say that the spacecraft has to be completely magnetically clean. Means the spacecraft itself should not have any magnetic field which can interfere with the external magnetic field or the IMF that we plan to measure. But typically it is not, because making a magnetically clean spacecraft is extremely difficult, and the cost becomes few times actually. So in India, right now we do not have, but what the best we can do is that we can make the spacecraft taking all the precautions that we can take, and of course we can use a boom. A boom is a big, I mean, I'll come to that. So these are the missions that are sent to L1 point as of now. You can see the blue ones are the ones which were having magnetometers on board, and the red ones are the one which were not having one. So the first one is that ISE, that is International Sun Earth Explorer. Its name was later on changed. It became ICE, International Cometary Explorer, and it was it was a joint mission between NASA and ESA. It was launched in 1978. Then, of course, WIND came in 1994. And, of course, ACE came 1997. And this was the vector helium magnetometer, which was sent on board ISEE. You can see over here. This is the spacecraft ISEE itself over there. And these are the two, the WIND and the ACE. Top one is WIND, bottom one is the ACE. And this magnetometers on board this were designed by the same team at Goddard Space Flight Center. And you can see they were 3-axis FGM. The range was plus minus 4 nanotesla to 65,536 nanotesla. That is because you have to calibrate these magnetometers on board at ground actually. And we have to nullify the Earth's magnetic field, which is typically from some 35,000 nanotesla to say 40,000 nanotesla. 8 dynamic ranges were there. They were almost identical except for that orange part, which is there for the ACE. The boom length for WIND was 12 meters, but for ACE it was 5.2 meters. And of course, the frequency, the response frequency was also there. And power for ACE, it was a little bit increased from 2.4 watts. Otherwise, it was both the things were identical. Not much difference was there in that. This is what I was telling. Our spacecraft looks like, Aditya L1 spacecraft looks like. There are some 7 payloads on board that, and we are using a 6-meter long boom, and 2 sensors are there almost on the middle, if you can see, and at the tip. And this we have done so that the spacecraft magnetic field can be neglected, and we'll be using it in a differential manner so that the spacecraft field can be cancelled out using the differential mode. And some of the parameters that we are of this magnetometer are given over here. It's a dual triaxial ring core sensor, and the ranges are 4 ranges are there, plus minus 256 nanotesla. We'll be using this range once we'll reach the L1 point, because we are not expecting any magnetic field above than this to come over here. But in the worst case scenario, if it gets saturated, we'll switch over to the 5,000 nanotesla range. And of course, 6,000 is there because we want to test this at the ground. These are the resolutions. For 256 nanotesla, it is 0.5. For 6,000, it becomes 2 nanotesla, sorry. And these are the accuracies, 0.1 and 8 nanotesla. Sensor noise is very low, and we'll be measuring 8 vectors per axis per second. That means at every second, we'll get 8 BX, 8 BY, and 8 BZ. Total power is around 2 watts, and mass, sensor and electronics is around 3.3 kg. The boom has a separate mass, which is a little bit bulky, something like 10. So total it will be around 15-16 kilograms. We are in the last stage of finalization of this thing. So this is how, as I was telling earlier, how we remove basically the spacecraft contamination. If you have 2 sensors at B1 and B2, and these are the distances, how you can see that you'll be measuring this and this. And of course, once you measure BIMF, only the measurements with B1, B2, and X and Y come into picture, and the spacecraft field is basically isolated. And this is how, if there is a contamination, how much magnetic field we'll be looking at the boom, if we have a 6-meter boom starting from 1000 nanotesla to all the way up to 10,000 nanotesla. So the details are not there. They're already in this paper, which is published in Advances in Space Research. If anyone is interested, they can go. Lot more details are given in this paper, which is given over here. So now I was telling earlier the solar plasma wave detection, which is my part into that. Basically, the objectives are, I can tell over here. The first thing is that we want to measure the magnetic environment at L1 point. What is the IMF which is coming over here? Every day we want to measure that thing, and that will be the first thing we'll do. Second thing, as I was telling earlier, we want to observe the CME. And as I told earlier, when the CME occurs, the normal magnetic field, which is something like 5 to 10 nanotesla, becomes a few times or 10 to the times more than that. It can go 100 or so. So once this CME starts passing through that L1 point, our magnetometer will start showing an increase over there, and then it will remain high as long as the CME is passing. And after the passage of the CME, the magnetic field will drop back again. So that is also what we want to do. The third thing that we want to do is that we want to measure, we want to do the space weather studies. What we will do, we will measure the magnetic field over there, and then we will extrapolate this magnetic field to the near Earth environment. Okay, so that means just outside the Earth's magnetosphere. So, and then we will see what this magnetic field, how this magnetic field basically will affect our Earth's magnetosphere and what will be its implications. That is the third point. And then the last one is that we want to do, if this magnetic field, with this magnetic field, can we do some solar plasma wave studies and all, which is my basically part of that one. So we, as I told earlier, Alfvén waves are there in the interplanetary medium, but it is believed that they have their origin near the sun, simply because for Alfvén wave generation, we need very high background magnetic field, because as I told earlier, it's a magnetic disturbance. Then magnetosonic waves, they are just the cousins of Alfvén waves. Alfvén wave moves along the magnetic field lines, whereas magnetosonic waves moves perpendicular to the magnetic field line. That's the only difference. Otherwise, these two things are same. And these inferences, what I'm telling is that by in 1974 and 1999, they were made by indirect estimation of plasma wave parameters and not in situ measurements, because you need a plasma wave detector for that, which is a suite of few instruments. You have to have electric field measurements, you have to have steady state magnetic field measurements, you should have like this is what we need: the time varying electric field of the plasma wave, or the time varying magnetic field of the plasma wave. In case it is a electromagnetic wave, need the density part, the electron density, you need the electron temperature, and of course the background magnetic field. So this is what is required. But in this case, what we will be having, we'll be having only this much. So like we used to have a quote and we look for the matching buttons. But in this case, what we are having a button and we are looking for a suitable quote for that. So which is definitely not straightforward, definitely not easy. It's a very tricky thing. We have just made an attempt because the idea was that once this data starts coming to us from the L1, the Aditya L1 magnetometer, in terms of plasma waves, what we are going to do. So what we do a background study. I mean, let us see the data which is already available in the public domain from the missions which are present over there, like at L1 point. This is not the scale, just a pictorial representation only. The WIND, which I told earlier, 1994, and ACE 1997. So we started taking the data to 2013, 2014, 2015. One project student was there with me. Along with her, we just started taking, seeing what is there in that data. And then this is what we found. In one day, we found January 10, 2015. This is just an hourly data. This is not a wave. This is just the magnitude of hourly magnitude, which was measured by the magnetometer on board ACE and WIND. The green one is the ACE and the red one is the WIND. And this is a magnetic field over here. And we plotted for the whole year. And then we started daily, whether we are seeing, we saw all sorts of things, but few days we saw over there. So once that pattern was there, we started looking deep into that pattern. Okay. And this is just one example. There were multiple examples. I'll come to that. And then once this was done, you can see beautifully, there is a slight separation between the two, because the spacecrafts were, if you see over here, this is XYZ in terms of Earth radii, where the green one is again the ACE, red one is the WIND. So the spacecraft was separated, but the same thing was seen by both the spacecraft. Almost like same pattern was seen around L1 point. So what we basically infer from that, there is a growing wave amplitude. You see the magnetic field increases, then goes down, then increases, then it goes stabilized, but still is, if you put, you can fit a straight line in between this. What could be this? This could be because of the Alfvén wave, simply because Alfvén wave are coming, they have enough power along with that. So for the time being, temporarily they are modifying the magnetic field part over there. And then to do Alfvén wave, as I told earlier, what we did, we basically make a correlation between the particle velocity and the magnetic field. And this is what we get. For wind, we got a very good correlation of 0.66 between the magnetic field and the particle velocity. And for ACE, we got 0.74. So this gives that these are the signatures of Alfvén wave, which we have seen over there. Of course, we need the particle velocity data also along with that. But this exercise was done for a few other days also. It wasn't, there were few days, I mean, and which is there. I'll come to that, I mean, where it is there. So the reason for this Alfvén wave generation was that it could be because of the coronal mass ejections, as I told. Solar flares are another candidate by which this Alfvén waves can get generated. Solar magnetic storms are there, with which it can also get generated. Magnetic reconnection is another. So these are the 3-4 candidates. So for one particular, like you see in this, it happened on February 12th, 2014. Same thing again, green for ACE, red for wind. And the magnetic field from 4 almost increases up to 8 nanotesla. So we thought something is happening over there. Let us just see the chronology over there. So this was measured on February 12th. February 9th, there was a CME report, event was reported, and February 9, 2014. Then what we did, and the typical CME velocity was given as 650 kilometers per second. Remember, I told you, so normal solar wind speed is 400 kilometers per second. So it is increased, of course, because of the CME. So we calculated the time from the sun to the L1 point, how much time this will take to reach over there. And it came out something like 5.5 hours to reach L1 point. And then the observation in this magnetic field, the changes basically that we start. Of course, the instant intensity was not that much, but it was sufficient to give the indication that the Alfvén wave was there. And this time factor basically matches well with the Alfvén wave signatures. We tried to do it for all the days that we were interested, and we found some patterns over there. But because of these are other examples, like January 3rd, you see the magnetic field was up and then it goes down. And then, of course, on January 30th, 2015, it started, goes up, and then goes again down. But we could not do the correlation for all the days, simply because for most of the day, the solar wind proton velocity data was corrupted over here. And basically, the sensor got saturated, and that we could not do. But enough indications are there, and we are prepared now. Once that L1 Aditya L1 magnetometer starts sending the data, what we are actually going to do with that. So all these details what I have told regarding this solar wave, this Alfvén wave signatures are written in this paper, because by the time actually I submitted for a conference paper, but the editor said that why don't you write a full-fledged paper onto that one, and then I wrote, but by the time the student has left, so I have to do all the things. So that's why that single author name is there. It is there in that. If you are interested, all the things are given. What I have told is available over there in this. So this is what I wanted to tell you. If there are any questions, I mean, I'll be happy to answer.
Yeah, please.
Thank you very much, sir.
Yeah, please.
So he has now 2 questions actually. The
Yeah.
participants are 2 questions. Okay. So first question, sir.
Yeah.
Sun magnetic wave causes aurora boreal and aurora borealis in Earth.
Sir, that actually is done by, you see, we have Earth is shielded by a magnetic field. Now what happens is that the charged particles that are coming from the sun, they energetic charged particles, all of them cannot cross this magnetic field and come into the Earth. What they are trapped with those magnetic field lines, and they start propagating around those field lines and goes to the 2 poles. Now we know that when charged particles get accelerated or deaccelerated, they emit electromagnetic radiations. So these auroras that we are seeing on the North Pole and the South Pole is because of this acceleration or deacceleration of charged particles. The color that we see is basically the transition between the energy bands.
Okay, thank you very much.
Yeah.
So his question was actually, does magnetic waves from the nearby stars and nearby galaxy and further causes the Borealis effect, and how much is it effective?
Sir, in other planets also it has been seen. Auroras are seen. They are seen in Jupiter. I think in Mars also they have seen. No, not in Mars. Jupiter, I think they have seen. So it was reported. So stars, I do not know. Stars have magnetic field. Galaxies also have magnetic field. But I don't know how. I mean, whether we have detected over here. I mean, I don't know. But sun and planets, of course, and comets also have magnetic field. But that is mainly the IMF which get accumulated over there. The comets, they themselves do not have any intrinsic magnetic field as such.
Okay, thank you very much. So the next question from the same participant, Kamal Talukdar. What are the significance of other Lagrangian points like L2, L3, L4, L5 besides L1?
Yeah, that is a very nice question. Yeah, each one has its own importance, as I say, because the L2 point, basically, if we have to see the deep space away from the Earth's magnetosphere, if we have to study, L2 point is the best one. Second thing is that if we have to study like switching off sun, if we have to see like the experiments, the coronal studies that we do during the eclipse time when the sun is basically blocked or masked, if we have to do those things, those kind of studies, L2 point is the best for that, because the Earth will basically shield out or mask the sun, and then we can see those coronas and all those things which are happening, flares and eruptions and all these things. For the best point for that is L2. Now L4 and L5, as you correctly said, very important, particularly L5 point. That is because if there is any, we know the sun is rotating around. Okay, so if there is any extreme solar event which is happening and throwing out a lot of matter or so, it will reach L1 point almost like 96 to 120 hours before it will reach Earth. So we have a lead time of something like 4 to 5 days. Okay, 5 to 6 days. I mean, like that, 4 to 5 days, where we can take some precautionary measures to basically protect our satellites from that extreme event. Either we can shield them behind Earth, or we can simply switch them down, or we can raise the orbit or lower the orbit, or whatever is to be done. So L5 point is the most important point if you ask in that fashion, because L1 point will receive the information only 1 hour prior to that, but L5 point we can get the information 4 to 5 days in advance. So we can switch off our power lines. We know when the event will be hitting the Earth 5 days in advance, which is sufficient time to take enough precautions if we want to save from something which is dangerous for, or not suitable for the normal life. So that is why. And L4 is again important in the sense, but the thing is that it is above before Earth. So anything that is reaching L4 will be after reaching Earth. So but the thing is that if you want to see the sun Earth line, okay, if something CME has started and going towards the Earth, if you want to look at as an observer from a third point, L4 and L5 are the best ones. You just sit over there, simply watch the sun Earth line, and you will see that. So these are the importances of all this. What is that called? Or L3 also in the same fashion. You put a satellite over there. What is happening? Like anyway, Earth will be passing through that, and it will be below that. Actually, 2 satellites, if I remember correctly, Stereo 1, 2. Are launched in 45 degree away from Earth, like one is here and there, but since the velocities were not constant, basically the distance between them starts increasing and all. So I don't know whether they are where they are now, but it was there. So these are the importance of this Lagrangian points that we are talking.
Okay, thank you. So the next question asking by Risnalin. Is there any interaction between Alpine wave and solar wind plasma in the interplanetary medium?
Yeah, as I told, solar wind is regularly coming in the solar wind, because we know that this need plasma medium basically, because the ions are picked from that plasma medium, and you need a background magnetic field also. So it is coming along with that with a typical velocity of 40 kilometers per second. Regularly it is coming, but normally the intensity is very low, so difficult to detect in that sense. But sometimes when some event is there, the intensity increases, and the amplitude becomes sufficient enough so that we can detect it, or the signatures at least we can detect it. But it is an integral part of solar wind, and it is coming always. We have observed Alphen waves near the Venus, also near the interplanetary medium also, but it cannot generate over there. The origin is always linked to the near the sun. So they may have get generated near the sun, and then of course they have propagated in the interplanetary medium. And I think near the Mars also, there was one paper by Argon. They have seen the Alphen waves.
Okay, thank you very much. So now, Professor Ekegogoi sir, so you can.
Yeah, I think it was interesting. Definitely very interesting talk. I think, right, from a very practical person. Dr. Yadav, thank you very much.
Thank you, sir. Thank you for
the
inviting me.
time.
And yeah, sorry for this shifting, but the meeting is still going on. After this, I'll again go back and join the meeting.
Well, that was, thank you very much. Thank you.
Okay.
Yeah.
Welcome, sir. Yes.
Okay.
Sir, I will leave the meeting now. Okay. Please carry on.
Okay. Yes. Thank you. All the best.
Thank you, sir.
Thank you, sir. So you can ask the next oral speaker, Dr. B.N. Hazarika, to deliver his talk. Professor Ekegogoi sir.
Hazarika, Professor Hazarika is ready, I think. Professor Hazarika.
Hello.
Professor Hazarika, are you ready? Professor B.N. Hazarika. Hello. Hello. Professor B.N. Hazarika.
Hello.
Hello.
Sir, yes, I'm on dealer.
Hazarika, are you ready?
Yes, sir. Ready?
Okay. Fine. Okay. I think that we can start the talk. We are, I think, next. Our presentation will be. Hello, voice. There's small
Yes.
problem with the voice.
Yes.
Hello. Yeah. Next talk is by Professor B.N. Hazarika. He is currently working as a Dean, College of Horticulture and Forestry, CAU, that is Central Agricultural University, Pasighat, Arunachal Pradesh. Professor B.N. Hazarika has guided several PG and PhD students, and also handled several externally funded research projects, right? And also done as a very actively, he has trained many people. Trainings, he has done quite almost 90 trainings. He has organized 90 training program kind of things. He has many papers in his name. In fact, 245 popular articles he has edited, and popular articles. He has 25 conference papers, and also book chapter, and also practical manual he has in his name. So the Hazarikas, we will be talking about underutilized horticulture plants of Northeast India and their potential. His co-author is B.R. Fukan, also originally from the Central Agricultural University. I think he is currently at ASTU. Okay, I think Professor Hazarika, you can carry on. Hello.
Yes, sir. Yes, sir.
Yeah, yeah, please.
Hello.
Uh,
Sir. Am I audible, sir?
Yeah,
To you, sir.
audible is slightly, there's a small problem, I think. Hello.
His voice is breaking, in fact.
Yeah. Yes. Let's look at the ASTU site, what can be done.
Maybe Dr. Hazarika can share the slides and put the video up. That may, because
I think, yeah, I think Hazarika can put the slides.
Is it visible?
No, Dr. Hazarika,
Hello?
you can reconnect. Dr. Hazarika, you please reconnect.
Is it? Am I visible and audible?
Dr. Hazarika, I think
Hello. Am I visible?
you are not visible, but it seems that your screen is coming up.
Yes. To you. Now.
Just wait, I think it's your screen is has started screen sharing. সুভাষ প্রবলেমটা কি হয়েছে হ্যাঁ ইন্টারনেট
This is at his side. Actually, Dr. Fukon,
yeah
this is actually Hazarika's, I think, his resource is very less. That is why he has to switch off his video. Then only I think he'll be able to speak.
ভিডিও তো বন্ধই আছে স্যার
Yeah, that is what I can see. That.
only his that internet is too slow.
Not happening. The screen sharing does not take bandwidth. I think that is.
Yeah, that is also true, sir.
It doesn't take bandwidth. I think it's a real bandwidth problem actually.
Next.
Yeah, now you are visible.
Is it okay?
I think
A bit improving.
I think it's still not coming properly. Your bandwidth may be very low.
You can go. I'll be during lunchtime. It will be okay.
Okay, I request Chairman sir to go to the next, and Dr. Hazarika will join the next. I think the PK Bora. Chairman sir, please. Chairman Gogoi sir. Hello. Chairman Gogoi sir. Hello.
Gogoi sir is muted.
Yeah.
Is it okay? Is it okay?
Okay. Now
Hello?
he's coming.
Okay. Fine. I
Yeah,
think
sir.
then I think if the Hazarika is not Hazarika, we can postpone, right? I believe. Then probably if next one was basically by PK Bora part. Can you start the PK?
Yeah. I'm ready with my presentation.
PK Bora. Yeah, I think we should start the next one. PK Bora, the smart water management experience.
Hello, am I audible? Am I clear to everybody?
Yeah, please.
Yes, you can proceed maybe. Yeah.
Okay. I think then, Dr. Bora, please.
Good morning, everybody. This is Pradeep Bora from Central Agriculture University. I'm basically an agriculture engineer working in water management aspects. Well, so respected chairman, sir, and all the panelists, and then also I thank the ASTU for giving me the opportunity. So I'll be just sharing some of the experience and then the future prospect of smart water management in agricultural sector, because we understand that the agricultural sector is the biggest freshwater consumer in the world, and then I'll go through some of the information already available in the public domain. So let me full.
Yeah.
So you see that. If you look, this is already available in India Water Portal.in, so anybody can go through it. So you see that 54% of India faces high to extremely high water stress, and then 54% of India's groundwater wells are decreasing, and more than 100 million people live in areas of poor water quality. So those people who are living in Guwahati, they understand that how groundwater is a problem in Guwahati now. Already we have depleted all the water available in the confined aquifer or the sparse aquifer, whatever available in Guwahati hillocks or the Guwahati underground region. So now it's not a problem of Guwahati, it's a problem everywhere. We have depleted groundwater to such an extent that I do not know whether the future generations will be having sufficient water. If we go through the other statistics, then we find that present water utilization in India is around 65 BCM, and expected demand by 2050 in high water demand situation, it is going to be 1180 BCM. So there is really going to be a big crisis. See, per capita availability by 2011, it was 1545 meter cube, which is lower than the Falkenmark standard of water stress. That means we are already living in water stress situation in India. And then when you look at 2015, then we will find that 1140, that means we are just approaching the water scarce situation, and this is really alarming. And you can see that sector-wise use, the irrigation is 78%, domestic we use 66%, industry is 5%, power is 3%, and other sector is 8%. Other sector includes, of course, the recreation, environmental requirement, etc. So when you think about the 2050 scenario, we'll find that irrigation is losing some of the water to other sectors, and around 10% water it has to part with. And domestic will be increasing because our living standard is increasing, the domestic water requirement will be increasing, and industry is also going to increase. At the same time, power is also expected to increase because power and water has a very big nexus, and it's still difficult to break. However, since we, as a whole, the whole country is going for renewable energy sources, perhaps to some extent that nexus can be broken, and maybe that instead of 6% requirement, it may still be 4.5, 4% if we go for renewable energy sources, where water requirement is a bit lesser than the conventional thermal power generating station. So looking at the efficiency side, you'll find that, see, the approach paper of 12 plan period, now when our plan period is not there, but when 12 plan period was prepared, the approach paper was talking specifically about the efficiency increase. If you look at the efficiency of the irrigation, then you see that it is conveyance losses is so much that efficiency is only 50 to 60%. If you surface line irrigation, then 70-75%, of course. Then depending upon the design of the irrigation system, how you irrigate the field, the crop, that also indicates the efficiency differences. Then overall surface water efficiency, you see that 30 to 60%. That means 70% water we lost during conveyance and application in irrigation sector. And when you go for groundwater efficiency a bit higher, and at the same time, you can see the urban water supply, where leakage and overuse, overflow is a major source of water loss. And as a result, we can find that 50 to 60% efficiency we can achieve in urban water supply. And in rural water supply, of course, a bit higher, and industrial use is, of course, 80%. So this is the efficiency side. And when we go for the expected efficiency, which is possible to increase, so in irrigation sector, instead of 30%, we can achieve 60%, and by that way, we can save water to 102 BCM. And by that way, you can see that almost 25%, precisely 23% of water can be saved if we can increase the desired level of efficiency by certain technological intervention. That what other interventions can talk about? First, one has to identify where exactly water is lost and how we can plug the holes. And secondly, whether the system can be made smarter, but at present it is only human managed system, it is not smart system. Can we manage it? So there are two things. Of course, when we talk about water, the smart system, it basically came from the integration or networking of the domestic electronic gadgets. See, we all know that by using your smartphone now, you can control all the gadgets at your home. So that is, of course, some kind of the IoT or the Internet of Things. And then that your whole house can be made smarter. And when you talk about the smart city, then also water supply, so electricity supply, all are to be made smart, and this require definitely some kind of IoT infrastructures. So when we talk about the different level of losses, you can see that we can talk about production catchment level losses, crop level losses, plant and leaf level losses. So the plant and leaf level losses, we are not going to do anything because it is a physiological aspect, and if we want to reduce the water consumption at physiological aspect, then our productivity is also going to be hampered. That's why we do not touch that. But at the catchment level and crop level, we can definitely improve much of the efficiency, and then we can improve our water availability for the next generation. So water productivity term, of course, very much used where we talk about the per unit productivity for per unit use of water. But now is that instead of water productivity, we are basically using the water footprint. Water footprint indicates that from the production level to the consumption level, whatever water is consumed at different stages that we talk about. So if we identify each and every aspect of the water used by the production system, then obviously we can improve our efficiency to greater extent. So what is smart water management? Actually, smart water management implies the data monitoring, acquisition, transmission, management, and presentation of the service in a manner that enhance the efficient usage of resources. So smart water is something as a catch-all expression. That means obviously in a management level, we need a lot of information. It's a crop information, crop consumption of water, then weather information. All this information are basically the database that we need to create. And from the database, we have to take a management decision. So human management decisions, basically, it's always a time lag is there. When we get the weather data, then from weather data, if we go for the weather forecasting, etc., there's statistical tools are required. So it's a whole lot of calculations and management decisions are to be taken. So it's never be a real-time one. So at present, it's very difficult to have real-time management for any aspect in agricultural sector vis-a-vis water management. So what is the real-time decision we are talking about? This is in smart water management, obviously, we are talking about real-time decision and efficient application. So here it basically will address use water only when it's needed, use only the amount that is required by the crop, and apply where it should be applied. So basically, again, we have to go back to precision agriculture concept, where we say that right time, right location, right amount, right method, right tools. So these are the concepts that we follow even in the smart water management system. However, when the database is too large, then obviously now there must be integration of all big data analysis, cloud computing, then fog computing, etc. But all the things will be decided by the smart system. So these are the fundamental requirement of any water management aspect. So we have used in two different projects. So one is a water soil moisture studies in the large cardamom area of Sikkim, and another for a lysimetry study. Then we have the experience of this sensors which can be connected to data logger, and all the data loggers now can be networked, and finally we can. But here what we used, it's only one-way data transmission system we use. Through GSM we connected to the sensors to the data logger, and data logger is connected to the sensor, and we used to get data, and which is again gone through the statistical analysis, and we decided water management aspect there. But this is what I'm talking about. We need to go a further step ahead to make everything smarter. So this is another aspect of the water management. We use the sensor-based lysimeter through which we determine the exact water requirement by different crops, so which can be again used for our system design, so that the system, smart system can be operable. So what our experience say that all the sensor that we have used, that they are very handy, no doubt. They're robust also. We got data accuracy provided if you calibrate them properly to the soil characteristics or whatever available in the installation site, and then you always get a very seamless connectivity to the data logger. But at the same time, these are very costly. At present, 300 to 500 euro you have to pay for single soil moisture, soil temperature sensor. So obviously 500 euro or 300 euro, it's not affordable to any farmers. These are only at present available in the experimental site, and people are using for different studies. But the thing is that this has to be brought down to the consumer levels, and possibly this can be manufactured in India, because the technology is not very you can say complex. It's only the dielectric constant concept has to be used for the moisture sensor. And then another problem we found when we use that moisture sensor prone to inaccuracy when saline condition is prevailing in the soil. And then also another peculiar problem we found that the termite damage was very much prevalent when we installed in the large cardamom area, because this is not a waterlogged area. The termite could easily move around, and moreover in Sikkim there was a problem of the blanket ban of any chemicals we could not use because that's an organic farming area, so we could not control the termite in our project area. And data logger, we have lost 2 data logger during the experiment period because of the lightning. So these are the certain problems we found, but otherwise the sensors are ready and they can be used and networked for any system. So what I find that making this system smart, we need all these sensors which can be capable of networking, because these sensors that we have used, they are not capable of networking at this moment. They are just directly connected to the data logger to collect continuous data. And another big problem is that since the data loggers are collecting data for every 3 minutes to 5 minutes, of course we can adjust it, but even then 5 minutes is good enough for that 5 minutes data interval means it's a huge amount of data you gather, which cannot be studied or cannot be analyzed by human being. So these are certain problems that we have to overcome. And devices with different communication protocols are there. So different companies are producing different sensors. So these are to be brought to the same platform, and then we need to have to integrate them with our own software. And data volume, of course, I already told about that. The data volume will be 2 layers, and obviously we have to go for cloud company as well as fog company or edge company, whatever you call them. So these are the ways that we need to think about. But the most critical part is the framework or the architecture of the IoT system. Well, you can connect them, but to translate into a DSS or decision support system through the IoT-based network, we need to have quite a sophisticated framework. So that is a big area for research in India. And of course, we have got only limited, a few networks are available in laboratory scale, SWAMP and FEWARE. These are the things available at this moment. But one has to remember that recently Karnataka has given a large area irrigation project to an Israeli farm. So this is again, they are telling that entire drip irrigation program, which will be benefiting nearly 60,000 farmers in Andhra Pradesh and Karnataka together. So this is how their system is having human brain. That means the IoT is now having the AI as well as the all kind of DSS system there. So this is what a framework we need to make the irrigation system smarter. That the source of water source, obviously it will be supplied to the field level through canals, pipes, pumps, olive valves. These are to be made smarter. That means these are remote control or sensor control system we have to have. The canals will be gated, which can be controlled by the sensors, and then pipes and pumps also to be controlled by the sensor. At this moment, the pipes and pumps and all valves are being controlled at the automated irrigation system under protected cultivation in drip irrigation system, but this has not come down to the larger field level, and then it has to be thought of. And then the field water consumption is a very important aspect, because we need to know exactly how much water is required in the field, and it is at present judged by the farmers. But that farmers, instead of farmer judgment, if you can accurately measure at a location, particular location, which will be assisted by GPS, and the sensor will be giving us the data. And if you go for a larger area, then drone is already available with us with that kind of sensor, so we can gather all information. And then at the same time, the weather forecasting information can be included in our DSS system. And then the crop manager system, crop management systems also to be included there. As a result of the cloud, we can have the status of the water availability and the requirement of the water in the field level. And then we can have the prediction of the weather to decide upon the next course of action. Then we have we must have the crop management aspect, the knowledge of agriculture, and then maintenance and control should be obviously by the smart system. And if we integrate the entire system, then we find that our water saving technology can be brought to the field. And obviously, with the present pace of the IoT infrastructure and then the start of the coming of in India, I feel that very soon this kind of infrastructure we can have. And then in the end, I'll just conclude that smart water management in the agriculture sector is still limited to greenhouse cultivation, where sensor-based automation has been used commercially. And however, Netafim, that is an Israeli firm, of course, they have got Indian wing, Indian part also, and they have taken the program in smart drip irrigation system in Karnataka and Andhra Pradesh, and which is going to be benefiting around 60,000 farmers. That is a very good example to have the to create a pathway for us. And then the sensor is still very costly and needs to be manufactured. I can understand. I know that Tezpur University was doing something about the development of the soil moisture sensor, and I do not know whether that has gone to the commercial level. I have not kept track of it. And then IoT and smart application in water sector still in the laboratory scale. Very wide scope is available for R&D. I hope that those who are in electronics and then irrigation sector, they can join hands and then develop the smart sensor as well as the whole IoT-based infrastructure. And locally manufactured sensor controller and their standard protocols for the networking will enable us, the water manager, to achieve what is so far thought unachievable. So thank you very much. This is what I wanted to share with you. And thank you, Astu, for giving me the opportunity. Thank you.
Thank you, Dr. Bora. I think any queries? A very practical problem.
We have not seen any question so far.
Yeah, perhaps this subject is a bit offshoot from what we have discussed yesterday as well as today morning. That's why the participants are not so much acquainted with irrigation system management.
No, I think it is
Dr. Bora,
general domain.
work. Over to Chairman.
Yeah. It's basically, I think, interesting topic. IoT has come up in a big way,
yes.
and in fact, some places without network, with a mobile, not internet, SMS kind of things also is.
We have done it. We have done it. Through the one-way communication channel, we have already achieved this kind of sophistication.
You can do the control also, both way control and other things.
Both way control is possible. So that's we need. Only thing is that we need a framework of IoT and then a proper data analysis, how decision can be taken with the help of the decision support system.
Yeah, there is a question just now we are receiving.
Yes.
The question is, sir, is this technique be applicable for domestic water treatment?
Yes. Treatment supply for both, it is possible because water quality sensors are available, and with the help of water quality sensor, you can the system can decide whether you need to, you can consume it directly or you can recirculate it for refilter it, because there are different stages of filtration and water purification that can be decided by the system if you make it a smarter one. So sensors are there. Well, already water quality sensor, then water level sensor, all sensors are available that can be made easily a network. And then at the domestic, of course, already IoT per se in the domestic sector is in commercially available, because all the gadgets, electronic gadgets which are network capable, people are networking them and then using through their smartphones.
Any further queries, please? Hello, I think I
Hello.
think
I think we do not have more question.
Okay.
okay.
for this
Okay.
presentation.
Thank you very much.
Uh-huh.
Thank you.
Professor Bora, thank you. Okay.
It's
Thank
my
you very
pleasure.
much.
Next, is it Dr. Hazarika, BN Hazarika? Are you ready now? Dr. BN Hazarika?
Is it feasible? Yes.
Yes.
Am I audible?
Yeah, we saw your screen. Like BN Hazarika has started screen sharing.
So can I start? Is it audible to you?
Yeah, you are audible,
Is it?
but your screen yet to be visible.
I think Dr. Foucault, there may be a problem with the laptop there. So if he is using the old laptop, then
Yeah, it's coming now.
no, his voice will be having echo in that case. Because there are two Zs are there, and one is audio, other is microphone. But one is microphone, one is the earphone. Two Zs are there, perhaps. That's why it will be echoing. Just verify.
Is it audible?
Professor Hazarika, your screen is visible.
Yeah, you can carry on, I think.
Am I audible to you, sir?
Yeah, please carry on. Please carry on.
Okay, thank you very much for taking with me. So as I know, I'm from one of the remote part of the country that is there is a problem. Now the entire is horizontal plane remote India. And you know the north in the land magnificent beauty and the geography and cascade. Hello.
Hello, Hazarika?
Yes. Yes. Is it possible to hear? Can I proceed?
Yeah, you can proceed, I think. I think it is coming again.
Can I proceed, sir?
Yeah, I think now.
Hazarika, your screen is not visible. I think it may come again.
Okay. Okay, then, sir, what I do it is I will be trying towards proceed further. Sir, I can presently on.
Your screen is not visible. Something wrong, probably. Yeah, it's coming now. Please proceed.
You can go to slides.
Now, slides are visible, sir.
Dr. Fukan Sahab, can I go for it?
Please proceed.
Okay, then sorry for everything. I am now hurriedly going for my presentation. As you know, the northeastern region is one of the land of magnificent beauty, and 7.7% of the total geographical area of the country, who is conserving about 50% of the total biodiversity of the country. So, go now. Huh? Dr. Saab, Dr. Fukan, is it visible?
Yeah, please. It's
Okay
visible.
then. Okay, then it is around 50% of the total biodiversity is within the northeastern region, where the 65% is the undulating topography of the and 35% only the plain land. So, as you know, this is my dream created the northeast with the depicting the condition of the northeast region. And as you know, the northeastern region is having the climatic variation. It is ranging from the tropical to subtropical to alpine. And that is why the wide range of horticultural crops, wide range of agricultural crops can be grown. So if you see the situation of the northeast, the percentage of horticultural share is like this. So as you know, since I am talking about the underutilized horticultural crops, let us go to the first fruit crops. So among the fruit crops, as you know, the jackfruit is one of the most important fruit crops in the northeastern region, and it is not yet to exploit tremendously, because it has got a lot of potentials. So if you were talking of the northeast is the center of origin of the diversity of the number of horticultural crops and wild relatives and minor economic plants, and it is one of the biodiversity hotspot of the world, and it is having a wide diversity of horticultural crops like bean, brinjal, and yam, chili, banana, and various species, and more than 200 species of the orchids and medicinal plants are there. So if you are talking about the diversity of horticultural crops, so far estimation is concerned, so if you see the taros around 272 and yams is 200 and citrus alone is around 80 and banana is 120 and orchids about more than 7 species are there. So if you are talking the exploitation of the fruit crops, you see the jackfruit is now young entrepreneurs are coming and they are preparing a lot of processed product from the jackfruit. So if it is so, then in the days to come, there will be thousands of product will come from the jackfruit, because it is one of the prevalent crop in this northeastern region. And another very underutilized crop is your Beccaria sapida, which is also native to the northeastern region. And fruit is white, and this is also used for fresh vegetable as well as fresh fruit, as well as preparation of the different processed product like your preparation of juice and squash, chutney, and medicinal uses, etc. So again, the fruits are rich in protein, vitamin C, and sucrose, and calcium, phosphorus, magnesium, and iron. And these are some of the entrepreneurs of the northeastern region which are coming for various different kinds of the processed product from the horticultural crops. So if it is so, our northeastern region will be developing in this direction. So what I was talking about is that one of the important underutilized fruit of the northeastern region from Arunachal is your Phobia copriana. You see, this is the only crop available in this province and the entire globe. And this is a very interesting fruit crop available in this region. And so far the domestication is concerned, and we are working on it on Phobia copriana, which is available in the Arunachal Pradesh. The tree is like this. And another underutilized fruit crop is your Delinia. As you know, in Assam it is the special one, and we are also working on it, its nutrient content and all. And another minor fruit crop is your hog plant, Spondia spinata, and the Spondias is having a lot of variations are there. So these are in Assamese it is called Amora. So another is your, these are the Spondias species, estimation of the nutrients we are doing it. And another is your Indian red pear, which is also found in this region and having the various antioxidant as well as another medicinal and properties. So this is another sand pepper mulberry is also available in this region, and it is the major constituent of the glycosis and spondias, etc. So it is having the antioxidant and phytochemicals like this. So this is another species called silverberry, is also available in this region, and it is a good source of vitamin C and minerals and other bioactive compounds, including the essential fatty acid, and capable of reducing the incidence of cancer. And this is another is called natgol, which is a source of tannin and gallic acid and tartaric acid and citric acid. And as you know, this is also available in the jungles of the northeastern region. This is another fruit called bloodfruit, which indicates that it is rich in iron. So it is also found in almost all the states of the northeastern region. The fruit and seeds are used for curative measures of anemia. And this is another fruit called monkey jackfruit, and it is also belongs to the same family of the jackfruit. And the fruit exhibited in anti-inflammatory and antiviral and anti-cancer properties, and it is having the anti-aging activities also. These are the, as you know, the northeastern region is having the diversity of the jackfruit species, and we are working on it. And this is the cane fruit. You can say cane is bamboo, and cane is famous in the northeastern region. That is also cane fruit is also having the medicinal values around. And among the citrus crop, this is the hardcora, that is Cactus macroptera, where rain can be also used for various uses of medicinal purposes. And this is another the fig. This is there are thousands of different species are there, and among the northeastern region, these are some of the species are found. And so for the Garcinia is concerned, different kind of Garcinia like Rukohi thekera, Kuji thekera, Tepotenga, and Botekeras are found in the northeastern region, which is a native to the northeastern region, and it is a source of very natural diet ingredient, and it is a source of citric acid. And as you know, the northeastern region is known for the citrus species, and we have documented the citrus species of the northeastern region. And this is how we are just collecting the diversity in the College of Horticulture and Forestry like this. So this is how the underutilized horticulture crops are being displayed and viewed by the various dignitaries of the country. And this is how it is done every time we are doing it. So far the citrus is concerned, some rare species are also available in the states. As you know, this is the citrus citron. It is found in the northeastern region, and it is the, you see here only albedo is edible, and no juice are there. So this is like this, and this is their physicochemical properties. This is another species called sinkin, which is available in the Arunachal Pradesh, and it is also not utilized so far. And this is another citrus species called Citrus indica. So Citrus indica is, you know, this is the citrus originator, and it is only available in the state of Arunachal Pradesh and Meghalaya. And these are the people who are conserving this kind of your citrus species in this northeastern region. So this is the cross section of the citrus, and this is the Meghalaya biosphere where you can get this species only. And this is another species called Citrus amphola, where it is not so far utilized, but we can utilize as a rootstock. And this is another citrus species called Citrus jamberi, which can be utilized as a rootstock for the Casimandran propagation. And this is the grapefruit, which is full of juice, you can say, and this is very juicy fruit. And this is Citrus macroptera, which is also very local tribals people use for home consumption and medicinal purposes. And our Assam lemon is also very famous in this region, and it is originated only this season only, and this is a popular lemon of this region. And as you know, we are doing the planting material production and in our college and like this, and various dignitaries from the all over the country has visited so far. And we are also distributing this planting material to the growers and farmers of this northeastern region. And after that, you can see the different kinds of your another some Galani species are there. This is also having the bioactive compounds. And this is carambola, as you know, this is also very much medicinal properties we have. This is for chickenpox and intestinal parasites and headaches, etc. And jaundice also it is used. And this is rambutan, also available this in the jungles of the Arunachal Pradesh and others. This is mulberry. This is another Karonda species available and in the from dry areas of the region. And this is another species called nagatenga. It is called in Assamese, it is called nagatenga. It is very much sour in taste. And this is another species of Myrica spinat, and this is tamarind species, tamarind. So it is also known by everyone in the region, and pulp is used as a represent and carminative, and this is also having this antidiuretic properties. This is a prunus, and it is rich in vitamin as well as in iron. This is also available in mostly available in Meghalaya and Assam and the other parts of the northeastern region. This is Pyrrhia Persia, and it is also available. And this is the wild form of kiwi available in the jungles of the Arunachal Pradesh and others. This is how these peaks are coming up in this jungle, and this is a local peak of the Arunachal Pradesh. And as you know, this is amla, and amla is available everywhere, and it is the one of the important minor fruit crop, as well as now becoming the major fruit crop in the region. This is the Phyllanthus acidus. This is called Pura amlaki. So this is also very much common in this region. This is another Rhodesis species, and this is also very eaten as raw as well as processed and pickles and etc. So this is another the minor fruit available in this region. This is also another one, and this is also Zolfai. You can say this is also used for the curating ulcers as well as women diseases. And this is also another type of governor plum available, and it is in vitamin C and minerals like phosphorus, calcium, magnesium, and iron, etc. This is also bigoni. This is also very much rich in vitamins and as well as source of calcium and iron. And fruits are astringent and anti-dysenteric, and this is also mature leaves also are used for the snake bite, and young leaves are boiled and used for other skin disorders. This is Azalea marmelos, where it is available in everywhere in the jungles as well as in cultivated form, and it is also used in the diabetic and stomach complaints. And another is also available. This is also Zamun species, and this is available. This is also another species called Cordia. Its bark and roots are effective against the cold and cough and indigestion and throat problems. So the fruits made into the excellent pickle from here. And these are some of the diversity of the passion fruit found in the northeastern region. So among other than these fruit crops, there are thousands of vegetable crops which are underutilized and which are not commercialized so far. And one is your Parkia roxburghii, which is very much famous in Manipur, now distributed all over the northeastern region. So this is the Parkia roxburghii, which is a popular vegetable crop of the Manipur, and this is now all over northeastern region. It is spreading. And this is another very peculiar brinjal called bitter brinjal, which is available in the state of Arunachal Pradesh, and now it is growing everywhere. And these are the variability of the different kind of chilies of the northeastern region. This is the variability of the king chili of the northeastern region. Among the vegetable, the leafy vegetable is also very much important in this region, and there are thousands of leafy vegetables are there which are consumed by the local tribal people. And as you know, we are to explore the different kind of nutrients as well as minerals and vitamins on it, and we are to promote all these things. And apart from this, Northeast is a treasure of the medicinal plants also, and we are growing a lot of medicinal plants also there in the Northeastern region commercially also. And some are also yet to cultivate it. For example, Pyrrhia polyphylla, which is also very rare medicinal plant available in this region, and it is against the anti-tumor action. And Coctis theta is also very much endangered medicinal plant, you can say, which is used for malaria and eye disorder. And this is another black turmeric, also used as a tonic and carminative and tonic, etc. And this is giloy. Giloy, as you know, this is during the time of COVID. This COVID giloy juice is very important, and this is available widely grown in this region, and we are also cultivating it in a commercial form. So this is ginseng, as you know, this is used for body stamina as well as vitality. And these are available in the state of Arunachal Pradesh jungles. So these are some of the star anise are also, this is for against the bird flu. And this is the common yew, it is the anti-carcinogenic, you can say. Among these floricultural crops, as you know, the northeastern region is known for the different kind of orchids. And more than 700 species are available there. Still in the jungles, a lot of species are there which are yet to explore. And we have collected this kind of endangered orchid species in the College of Horticulture and Forestry like this. We have collected the different species from the jungles. And these are some of the, and this is the Siroy lily of the Manipur. This is a famous Siroy lily of the Manipur, which is very much endangered now, and we need to conserve it. So if you are talking about the common constraints, as you know, there is a lack of awareness among the farming community, lack of planting material, and limited application of the agro techniques, limited inadequate marketing support system and infrastructure facility, and lack of post-harvest management, and improper institutional arrangements are there, and these are commonly constraints available in this region. So if we want to be success, then definitely these underutilized food crops having the local and regional importance, and are also potential for contributing to food security and income generation and environmental services. And more germplasm need to be identified for collection, particularly for high yielding qualities and resistant to the pest and diseases and tolerant to the biotic steps. And more R&D need to be generated for both on the species crop and important for subsistence farming, and those exhibiting the potential become of commodity crops, and rapid expansion of the infrastructure facility with the priority on market development and storage, transport, communication need to be done. So with this, I come to the last slide, that is, thank you very much, Jai Hind, for patient hearing, and thank you for bearing the pain of the due to the poor network connection, as I am located in the northeastern, the very remote part of the country, that is Pasighat. So network is a very problem. So sorry for everything. Thank you very much.
In fact, I think Dr. Hazarika, it is wonderful. In your network becomes so good. everything is fine. Actually, it came very
Thank
nice.
you, sir. Thank you, sir. Gogoi sir, thank you very much, sir. Nice to see you.
Okay, all the best.
Thank you, sir.
It is
Thank you, sir.
wonderful work. I think we have to strive towards more. I think usefulness of these products we have to look at, right? I
Yes,
believe
sir.
that some work in the heritage drinks are also going on, I believe.
Yes, sir. Yes, sir. Yes, sir.
Yeah, okay. All the best. I think any
Thank you,
queries?
sir.
Any questions?
Yeah, I'm happy to answer, sir.
Yeah, thank you, Dr. Hazarika, for nice presentation and the work. And of course, we do not have any query right now. It's over to Chairman, Chair.
Okay.
I think
Okay,
next presentation can be started.
Thank you, Hazarika. Thank you. Then I think the next speaker is Diganta Kolita. Is it there, please? Diganta Kolita. Next speaker.
Diganta Kolita. Yeah, I think he is available. Yeah, Dr. Kolita.
Hello.
Kolita, please unmute your mic. What's wrong? Mr. Kolita is not audible. You are not audible.
Hello. Hello.
Kolita sir, apuni, hello. Kolita sir, you use your headphones. That might work. Not audible, sir.
Let's look at what is the issues. What is the issue basically? This voice came. Quinta can rejoin the things. I think you can rejoin the thing and try. Eh? Yes. Yes. Hmm.
Still not audible, sir. Maybe issue with your microphone. Can you use another laptop or computer? From another computer, you can log in because we are not able to hear anything.
Mr. Kolita, if it is not possible from your laptop, can you start from your mobile?
Well, actually, it will be difficult for me. Hello.
It's coming now.
It's coming, sir.
Yes.
Hello.
Yeah, please, now.
Yes, coming. It's coming. Okay, continue, please.
Thank you, sir.
Coming.
Thank you, sir. I'm very sorry, sir, for that. So I'm going to share the slide, sir. So is it visible, sir, slide?
Yeah, everything is fine. Go ahead, please.
Thank you. I'm very sorry, sir, due to my technical problem. First of all, can I start now, sir?
Yes. Please carry on.
Thanks to
Well done.
organizer for giving me the opportunity to present my research work. In this study will be helpful for the wood processing industry to join the bands of blade in economic way. It has been observed so blade width result decrease flexibility as well as the joint strength affected. Also observed that due to insufficient pressure or pressure is not controlled, the joint strength is also affected, and the grinding hoods used to prepare the workpiece selected arbitrarily, just randomly selected, and as a result, improper softness and causes the affect the quality of bands of blade. So there is a possibility need to study the effect and parameters to optimize the mechanical properties of bands of blade after brazing. The ultimate objective of this research work is to prepare for bands of brazing, especially for wood processing industries. So these are the outlines of my research work, and selected the range accordingly. Then design the experimental design and optimization of the parameters to achieve the goal, and ultimately evaluation brazing joint by different methods. So the factor affecting the quality of bands of blade are many types of failure, joint, surface roughness, weighting, types of joint, etc. So it's investigation process, all the parameters are looked into, and some of the properties keeping constant, and some of them cannot be controlled. So the experimentation is conducted considering that parameters only. So filamental use in this project is a brass. By 60% of copper and 35% of zinc, and it is able to make the seat. And the past user for as a and water, and the powder flux as a borax. So the surface toughness, normally the grinding process, we can prepare a surface toughness of 0.1 to 1.6 micrometer. So in my project, the range of grinding surface toughness is kept as 0.1 to 1.6 micrometer. And the contact pressure, as per from the research, from the other researchers, it has been found that the contact pressure should be more than 3.45 megapascal or slightly higher. And the weighting and the joint clearance is kept as 0.2 and the weighting effect is neglected by replacing the brazing foil between the joint. And only possibility is to join the blade is because after brazing or after joining, the thickness of the blade is constant. So it is very simple formula. Calculate the length of the brazing joint, putting the material values, it is about 1.11 mm. Then the blade rail manufacturers and these are by the manufacturer. And tensile strength is measured is about 1125 megapascal. The rock hardness number is measured in 611 in the laboratory. Then the methodology is there. First, you have to investigate the parameters, then selection of the property parameters, then the brazing in the we are using harness brazing. Then after joint stand hardness, all the mechanical properties are investigated. Then we have to optimize the joint strength by using software. Then solution purpose, joint thickness, network structure, and the life of the blades after joining were evaluated. So these are experimental stuff. Here, the muffle furnace is used with nitrogen purging at a rate of 8 liters per minute, so prevent the oxidation and so ensuring that there is no air leakage into the furnace. Then by measuring the surface toughness by millimeter, and chloride is to surfaces, and these are the fixer used to fix the blades for joining. Third for design experiment using some method. Next. Design. So the has 114 kilopascal to 50 kilopascal as per this author, and the surface toughness is as per the grinding process 0.1 micrometer to 1.6 micrometer, and the lapping length as per American Welding Society it should be 3T to 60. That means 3 mm to 6 mm because the thickness of the blade is 1 mm. Then these are the specimen prepared for tensile test, and these are the shear failure has been observed after test. And these are the experimental table, and all the experiments are conducted for tensile strength, and these are the corresponding tensile strength for a particular combination. Then the regression analysis, and we found that there is a good correlation between the predicted value and the actual value. The regression is the least square regressional analysis. Then it is under ANOVA test, and after ANOVA test is found that there is significant. Mainly the surface toughness and the contact pressure are very significant as compared to lapping length. These are the main effect plot when you consider the individual factors. Then we have found that the tensile strength will be higher at lower surface toughness, and the tensile strength will be higher at the high contact pressure, and the optimal lapping length is about 4.5 millimeter. These are interaction factors. The interaction of the factors, the effect or response is affected. So it has been observed that higher the tensile strength at higher surface toughness and higher contact pressure, and the length of contact is ineffective. Not normally it should be kept as 4.5 millimeter as per the calculation. In the calculation it is 4.1, but it should be 4.5 mm of length. Then these are the correlation equation or quadratic equation of the model. There is a relation between factors and their interaction effect and the tensile strength of the joint. Then these are the optimal solution. We have got 41 combinations of factors for optimization of tensile strength. The optimized tensile strength is kept in the range of 750 megapascal to 800 megapascal. And the probability of getting that strength is about 88%. Then the evaluation of the joint. So the joint should be evaluated for Now, there are three methods are used to evaluate the joint. First one, joint thickness, then microscopic view, and the dynamic fatigue life. So after evaluating the joint thickness by optical microscope, it is found that the joint thickness varies from 52.56 micrometer to 143 micrometers. And it is observed that in the figure, as we increase the contact pressure, the joint thickness reduces. Then evaluation of joint by microstructure. So normally the voids and the cavities as well as the cracks are present on the filler material. So it had been observed that we have observed some voids and cracks, and the size of the voids varies from actually 1,563 micrometers square to 17,130 micrometers square. So this one is at higher contact pressure and this one is at lower contact pressure. So it is directly dependent on the contact pressure as well as the flux uses. So these are the dynamic fatigue testing is done under uniaxial dynamic fatigue testing machine, and during testing the fatigue load or the tensile load is kept as 70% of the strength of the regular point. And it has been observed that the minimum life before fatigue failure is about 94,000 revolution to 1 lakh revolution, and some of the samples is above than the value, more than 1,50,000 cycles. So come to the conclusion of my topic. So the hardness is also measured. It is in the range of 43 to 55 Rockwell hardness number in C scale, but it is lower than the lead material hardness. It is about 63 because the hardness model is insignificant, and because it depends on the cooling process. Then the joint strength are influenced by the formation of voids and the size. Then the brass material is very sensitive to oxidation, so cleaning process and the control environment is essential. So influence contact pressure and the residual and the flux residue. So insufficient contact pressure and the flux residue forms cavities and voids within the joint. So the optimal strength due to interaction effect, that means higher surface roughness is about 1.29 micrometer and the high contact pressure 42 kilopascal, and the lapping length is about 4.38 mm. We have the highest tensile strength. For the reliability point of view or useful life, it is about 94,000 cycles to 1,00,000 cycles, and before first fatigue failure. So these are my references. Thank you, sir.
Thank you, Kalita. Thank you, Kalita.
Thank you, sir.
Okay, fine. There was some hitch was there. I think later on it was okay. Okay, this practical things has been done where it has been done, experiments.
So in Jorhat College.
Okay, nice. Thank you very much. So any questions from anybody else?
We do not see any question in the box.
Okay. Then thank you, Kalita. Then I think they have been a nice talk. Okay.
I'm very practical for initial. Okay. Thank you, sir. Thank you, sir.
Thank you very much. Thank you.
So thank you. Thanks to all the participants, all the invited speaker and the oral presenter to make this event very fruitful and nice. And I extend thanks to the chairman of this technical session, Dr. A.K. Gogoi sir, for his kind acceptance to lead this technical session. Thank you so much. I would like to inform you that the next technical sessions will start from 2 o'clock, and we have two invited speakers, and one from Sweden and another from France, and we have 2 oral presentation. So thank you so much. We'll meet again at 2 o'clock. Thank you.
Thank you. Thank you very much. Okay. Dr. Fukan, মোৰ হেৰি অভাৰ নহয়।
Hello? Hello?
মোৰতো তাত একো নাই ন পিছবেলা মোৰ ৰোল নাই ন পিছবেলা।
Sir, আপোনাৰ নাই কিন্তু আপুনি চাব পাৰিব আপোনাৰ লিংকটো এক্টিভ থাকিব।
না মই চাম মই চাম মই টকিটা চাম। ওকে
পাৰ্টিচিপেট কৰিব স্যাৰ।
মই ঠিক আছে থাকিম
Thank you, sir.
ঠিক আছে।
আপুনি কালিলৈ আপোনাৰ লিংকটো কালিলৈ এক্টিভ হৈ থাকিব আৰু নতুন লিংক এটা পঠোৱা হ'ব আপোনালোকলৈ।
আচ্ছা আজিলে এইটো লিংকে থাকিব না ঠিক আছে হ'ব ওকে।
Every day, I mean, a different link will be sending. Okay, thanks. Thanks, sir.
Oh.
Making everyday dishes delicious. Hamlet's world's #1.
ক্লায়েন্ট আর প্রয়োজন সানসেট ব্ল্যাক শাইন আমলকি পর্যন্ত এগিয়ে প্রত্যেক পোশাকের মাঝে যাওয়া শাইন ওয়েলকাম টু শ্রেয়া শাইন টিউটোরিয়ালস আজই মই আপোনালোকক শিকাম প্লেটার্নস অফ ডিএট বলিয়া সাইড মিনি ওয়াও তুমি ম্যাগনিফিকন সানসেট ব্ল্যাক শাইন যেতিয়া launched a huge protests which also led to violence at the time. Sam Daniel joining us at this point with the latest on that. Sam, how is this verdict being received?
Well, generally, political parties in Tamil Nadu welcome it, Angika. Just a short while ago, DMK chief M.K. Stalin has welcomed it, saying that he respects the value the court has given for public sentiment and also the need to protect the environment. And he has urged the ruling AADP in Tamil Nadu to adopt a cabinet resolution giving the verdict and to enact a law as well so that Sterlite would remain shut permanently, his words. And in Tuticorin, people, the local communities who have been fighting against the plant celebrated bursting crackers and also distributing sweets. Meanwhile, Sterlite, in a statement, has said it will explore all possible legal remedies and says it's discouraged over these developments, saying that there is a conspiracy to scuttle attempts to make India dependent on neighboring hostile countries for copper when India could be independent. And without saying that it will go to the Supreme Court, it has given a general statement saying that it will go and explore all legal remedies. And all these years, Tamil Nadu tried adaptability.
Then the statement says they are educated and have an IPS officer OP Singh in the family. The allegations are fabricated for ulterior purposes. Isn't this a brazen attempt, Swati?
Also said that she is not against a CBI probe, but is challenging the illegal investigation by the Bihar police, which somewhat doesn't make sense. She was the first one put out that tweet on Twitter, remember, which said and requested for a CBI probe into this incident as well. She has also denied reports of her meeting Maharashtra Minister Aditya Thakur.
Whatever has happened to his mental condition has happened only because of Riya and when Riya came in his life, not earlier. Because of the friction that she created in the family and what all she must have done to him, that only will come in a proper and fair investigation. And she never actually consulted the family if there was any medication in that. She was not his wedded wife.
Manish is now joining us with the very latest on this. Manish, just a while back, we broke two stories. One was on how Disha and Sushant were in touch. And the other story was on how Quant Talent Management Agency has made a stunning revelation of how Sushant made 30 to 35 crore rupees in the past 3 to 4 years. And they were managing him, so they know this better. And perhaps their P&L would also reflect the commission that is earned by them. The ED should be widening their probe now and finding out where did this 30 to 35 crore rupees go. And right now they're focusing on the allegation of 15 crore rupees that has gone missing from the account. It's a little of a mumbo jumbo right there. You have to clarify everything for us in terms of the financial trail and where does probe stand? That
The 15 crore rupees of allegation is by Sushant's family. What they maintain that when they went through the bank statement of Sushant Singh Rajput, they found that over 15 crore rupees in last 1 year have been transferred to the accounts which are not even related to Sushant Singh Rajput. They suspect it might be Riya Chakravarti. At the very same time, now this talent management company is coming up with revelations that the lead actor earned more than 30-35 crore in last 2 years. Now it is up to the ED to find out where did that money go and what actual is the amount currently in his 5 bank accounts. There is no disclosure made by the agencies so far, even by Mumbai Police, Bihar Police, or even by enforcement directorate, that what is the exact amount which Sushant Singh Rajput already has. And the beneficiary of these accounts is Priyanka Singh, sister of Sushant Singh Rajput. Now the lawyer has come out with a statement for Riya Chakravarti, and Chaiti, this is not only about what is going on with the investigation. There is also lots of social media. Everyone is giving their own opinion, and that is why it has turned into a perception building war. And in the same exercise, now the statement has come. There are 5 important points as of now. What when I went through the entire statement, one is the
Gunjan's own colleagues have now slammed the filmmakers, accusing them of twisting facts, while retired Wing Commander Namrata Chandi, who served with Gunjan, said that they never faced any kind of discrimination. Another former colleague, Srividya Rajan, said that facts about the Indian Air Force have been twisted in the movie and that she was the first woman pilot to fly in Kargil. In fact, after the controversy, even Gunjan Saxena has gone on record to say that lies are being spread to tarnish both her and the Indian Air Force's image. Let me go straight across to Flight Lieutenant retired Srividya Rajan, someone who knows Gunjan Saxena well because she was posted with her in Udaipur in 1996. Ma'am, thank you very much for joining us here on CNN News 18. It is good to see you. Can I just start by asking you whether you have seen the film and what you thought of it? You know, a lot of people have a lot of problems with it, gender bias, etc. What is your take on how the film has been made?
Thank you. Yes, I have seen the movie, and after watching the movie, I felt movie people have portrayed IAF and the people in uniform in a negative light, and it is wrong. And also, there were 2 lady officers, which is also not shown in the movie. In the movie, they are showing only 1 lady pilot got posted to Udhampur and 4 in Kargil area, but Kargil operation. So that is also incorrect. Two of us were posted to Udhampur, and then in Kargil also both of us participated. And yes, that's it.
Ma'am, you're saying, you have claimed, and I know this is a fact, that you were posted in 1996 in Udhampur as well. Were you the first woman to fly in combat in Kargil, or was it Gunjan Saxena? Because I think you were posted there a little earlier than her.
Yeah, yes, I was the first one to fly in Kargil operations. When the first set of crew went to Srinagar, I was the part of the crew. And I operated there in the Kargil, but I did not come out with this earlier because there were so many other male pilots had flown there much more than us, but none of them got any fame for that. And we always felt we are equal with our male counterparts. So only for being a woman, if I am going and asking for this fame, that is not right. And plus, here I'm not interested in claiming the credit of being the first woman pilot to fly in Kargil. My issue is with the way they have portrayed Indian Air Force and the personnel in it. They have shown them in a negative light, and that is not how it used to be. It was that time.
Ma'am, when you say that the Indian Air Force and its pilots have been portrayed in a negative light, why do you say it? Because, the fact is that the Indian Air Force may say it is a gender-neutral service, but when all of you were starting out, especially initially, things may have changed for girls now, but when you were in the Indian Air Force, are you saying there was no sort of bias, individual bias? I'm not talking about institutional bias. Are you saying there was no sort of individual bias against women who were operating
there? Because we were going to join an Air Force. It is a prestigious organization and going to be officers. And there were few people who felt, especially flying is a very high risk job. So they felt whether we will be able to cope up with the stress and the performance also, whether we will be able to perform well, because we were getting posted to J&K, and it's an operational unit. So they were skeptical about it. When I'm saying that, they were very few. Majority of the officers supported us. In fact, our seniors, after a few days, when they realized that we were worth it and we were performing well, they helped us so much and they trained us. Our seniors were teaching us. And the way the movie has projected, every time she was targeted and humiliated, nothing happened like that. And we were flying, right, the moment we joined there, and after a few days, initial formalities, we started flying. There was no interruption, there were no petty reasons cited and said you can't fly. All those things are like sending a wrong message about the institution and the officers there. It is wrong.
Ma'am, in a blog that you have put out, you also said that because you were women, you have to work doubly hard to prove yourself. Why was that? If individuals in the organization was not inherently biased towards women, why did women have to work, doubly hard compared to their male counterparts to prove themselves?
See, it is a male-dominated area. Men have already proved there. They've been working there for years. I'm from the 4th coast, me and Gunjan. We are coastmates. So when we went there, we were the first lady pilots. So they don't know how we are going to do and perform and fly. So they were, a few of them were skeptical.
Ma'am, if I could ask you, all this while, since 1999, the one narrative that has gone out was that Flight Lieutenant Gunjan Saxena was the first woman helicopter pilot in Kargil, the first woman to fly during the Kargil operations. This is a narrative that has been out since 1999. Do you think it has been a failing of the organization, that is the Indian Air Force as well, that they didn't step in to correct that narrative, that there was a second pilot as well? Her name was Sri Vidya. She needs to get the credit as well. More than Gunjan, do you think it's the Air Force that possibly failed on that count?
I think it is not the Indian Air Force who are at fault. It is the media, because when we were sent to Srinagar, we were given instructions not to speak to any media and give out information of the operations. So that time no media was allowed. And when the media came, that is the first few weeks I was there, and then second set of crew came. That was the time when the media was allowed to enter interviewing. So that time Gunjan was there, and I think that is how it went, saying that she is the first one. It is not the Air Force. I don't think Air Force has said anything on that front.
So where do you think Gunjan's failing has been, ma'am? You've seen the film, you know her personally, you've served together, you were friends. Where do you think she failed? Do you think it's...
I don't think she has failed anywhere. She is a very wonderful person and a very fine officer. We have been postmates, and we were posted to 2 stations together. Like almost the entire career we were together. And I don't think she will go and project Air Force all the colleagues like this. I think it is entirely the filmmakers have gone and twisted the facts, maybe to attract public attention or to sell the movie. But I can tell you, having known her for so many years, she will never speak like that about Indian Air Force or the colleagues, because they were really helpful and accommodating. Why would she speak like that? She will never do that.
My last question to you before I let you go, what would you say to all the young girls who have seen the film and probably come away feeling that the Indian Air Force is not a place for women?
Yes, this is what I was worried about. After watching the movie, I feel really disappointed, because it is project and it is a prestigious organization where we lady officers are serving, and it is not everybody going and working there. And flying was a very difficult, tough job. In that, please, if you show such things in the movie, they are sending a wrong message to the next generation, and that is incorrect. So I want to tell them that nothing of that sort takes place, and this is 24 years back, and now time has changed also. I'm not saying that time it was difficult, no, but of course we had to work hard and we had to prove ourselves since we didn't have any predecessors there. So now there are so many people already flying and proved themselves. If you you are aware that there are fighter pilots and instructors in lady instructors and lady fighter pilots. So they should not be disappointed by seeing this movie. This movie is just a commercial masala, I feel. It is not like that there. It is really a good environment, happy environment. Okay. Yes.
Okay. Flight Lieutenant Srividya retired, thank you very much for joining us. I think it was important to hear you today. Thank you very much, ma'am. And I do think that all the women who are serving in the Indian Air Force right now, whether they are pilots or not, have much to thank women like you who came before them. Thank you very much for joining us. With that, it's a quick break on the show. There's much more coming up on the other side. Do stay with us.
People have died, and our economy is in shambles because of a virus that this president downplayed for too long. It has left millions of people jobless. Too many have lost their health care. Too many are struggling to take care of basic necessities like food and rent. Too many communities have been left in the lurch to grapple with whether and how to open our schools safely. Whenever we look to this White House for some leadership or consolation or any semblance of steadiness, what we get instead is chaos, division, and a total lack of empathy.
We're facing the worst public health crisis in 100 years and the worst economic collapse since the Great Depression. We are confronting systemic racism and the enormous threat to our planet of climate change. And in the midst of all of this, we have a president who is not only incapable of addressing these crises, but is leading us down the path of authoritarianism.
Many of us have been deeply concerned about the current path we've been following for the past 4 years. It's a path that's led to division, dysfunction, irresponsibility, and growing vitriol between our citizens. Continuing to follow that path will have terrible consequences for America's soul, because we're being taken down the wrong road by a president who is pitted one against the other. He's unlike all of our best leaders before him, who worked to unite us, to bridge our differences, and lead us to a united America.
Let's now take a listen to Trump, particularly at Democratic convention, saying the address is already important.
Democrats are promising to elevate their left-wing war on cops and to bring it up to the White House in the form of Sleepy Joe Biden. I don't think that's going to work. You know, I noticed at their convention today, these are all taped speeches. Michelle Obama, her speech is taped. Why don't they tell me that? I'll tape my speech. Next week I'll tape it. It's a lot easier. I'll make sure it's perfecto. Every word will be perfect. If I don't do it, I'll give it 5 or 6 goes. I'll say, pick the best one. What is this? They're taping their speeches. I just learned that her speech is taped and that most of them are taped. I don't know. We'll have to speak to Republican leadership and say, let's tape those speeches. You want to go to a snooze? You know, when you hear a speech is taped, it's like there's nothing very exciting about it, right?
So after me, Chairman Aruna, this bulletin for the news and updates to log on to USA.in or download our app.
On one side, cricket no best captain MS Dhoni. The other side, but jogging marathon champion Mari best friend Usha. They both in a race. At the track, but nahi, focus last Bada aaya Dhoni Usha's in. How do you play on PokerStars.in?
The world is here at Shanta University. Where are you?
आप अपनी फैमिली की खुशी के लिए सब कुछ करते हैं,
लेकिन टर्म लाइफ इंश्योरेंस ना लेकर आप उनके फ्यूचर को खतरे में डाल रहे हैं। आज ही टर्म लाइफ इंश्योरेंस लीजिए policybazaar.com से। अब छोटे-छोटे मंथली पेमेंट्स में महंगा नहीं है। policybazaar.com, standard terms and conditions apply.
At the height of the India-China standoff in Ladakh, India Today reports from the heart of the story. The first channel to cover the strategic Durbuk-Shuk-Daulat Beg Undi Road.
Our journey begins at Durbuk at 14,500 feet and ends here at an altitude of 16,696 feet.
The first and only channel to reach India's remotest yet most strategic border post at DBO. India Today, keeping India first.
KR Mangalam University, an educational hub for innovation and creativity, ensuring a safe and secure learning environment. Your destination success.
करो viruses और bacteria पर attack. Savlon Hexa Advanced Soap के साथ. Savlon Hexa, Savlon Advanced Suraksha.
After a report claimed that Facebook India's top executive allegedly favored BJP MD T. Raja, saying the BJP has claimed that the Facebook's bigwigs are linked to the Congress party. Sources in BJP claim that the Facebook India managing director used to work for the Planning Commission under UPA. The BJP sources claim that a top employee of Facebook's public policy team previously worked for senior Congress leader Ahmed Patel and now allegedly publicly abuses the Prime Minister and his ministers. The party claimed that Facebook's former head of news partnerships contested 2019 polls on a Congress ticket. In fact, let's take a look at this whole slugfest and give you a sense of what's going on. This is an entire Facebook hate trial that is continuing between the BJP and the Congress party, and my senior colleague, Rajdeep Sardesai, had a power-packed discussion over this issue. Here's a look.
Whether the BJP has used the fact that it is in power to influence Facebook. The Wall Street Journal article suggests that Facebook public policy head Anki Das told staff members that punishing violations by politicians from Mr. Modi's party would damage the company's business prospects in the country. Your response, Tejasvi Surya.
Good evening, Rajdeep. My response is very simple, that this is a match fixing by the Congress party. The Facebook policy team, which is heavily dominated by the left-leaning Congress sympathizers in India and outside. And most importantly, also the Wall Street Journal, which is again not known to have sympathetic views towards nationalist voices in India.
Are you telling me Wall Street, sorry to intervene, are you telling me that Wall Street Journal is in cahoots with the Congress party, the Wall Street Journal?
Absolutely, no doubt about this. And if you go back and look at the kind of uncharitable views the Wall Street Journal has put earlier, they have never been sympathetic to the nationalist cause in India. So they are not something that is sacrosanct. They are not a sacrosanct publication which is bereft of any ideological shift or ideological leaning. So they are not ideologically neutral, Rajdeep. Let us keep that in mind. They are as ideologically committed.
That she was linked to Aditya Thackeray, because on that background that she has issued a clarification saying she does not know Aditya Thackeray and has never spoken with him, though she has clarified that Needu Moria, who is also known to be in the close circles of Aditya Thackeray, is somebody she knows because he is a senior in the film industry.
As we are getting a first reaction about Sushant Singh Rajput's.
Is it an impersonal algorithm based on certain objective criteria which is deciding what is hate speech and what is not? It is not. That is not the way it is being done.
In a statement that you have put out on Twitter, you have said many have complained that Facebook is unfairly censoring many nationalist pro. The fact is that Facebook has been censoring pages of both Congress and BJP. I have it here in my 2019 book. In that very clearly, Pawan Kheda, the fact is that there were, in April 2019, before the general elections, Facebook took down 700 political pages, Out of these 700 political pages, 687 linked to the Congress had 206,000 followers. 15 pro-BJP pages had more than 2.6 million followers. But Facebook claims we took down Congress pages and BJP pages. We took down Congress pages.
Rajdeep,
Yes.
the fact of the matter here is that we question the professional integrity of the Facebook, and guess who comes to the defense of Facebook? Ravi Shankar Prasad. Now, he is not, till last reported, a spokesperson of the Facebook. Today, Mr. Tejasvi Surya, of course, now they are doing it smartly, a little smartly as they can afford to. Says Facebook and Congress has a collusion, but is defending what Facebook does. This in itself shows not just an unholy collusion between Facebook and the BJP and the right-wing ecosystem, but they are trying to attack the messenger. I remind you of Cambridge Analytica. Before the elections, CBI inquiry, this, that, and other. Tell me if the whistleblower, Christopher, has once been approached by any Indian authority. I want to ask Mr. Tejasvi Surya.
All right, breaking news coming in. The Congress party has written to Facebook CEO Mark Zuckerberg of the alleged Facebook India BJP links. In their letter, Congress's alleged Wall Street Journal article suggests Ankhi Das from Facebook India has provided the party and the party with favorable treatment on election-related issues. The party demands internal inquiry of Facebook India operation and asks for a high-level inquiry in its report within the time frame. Let's listen in and cut live to Union Minister Ravi Shankar Prasad. Listen in.
All right. I believe we've lost Shaina NC as well. We'll quickly try and reconnect with her to get the BJP's reaction to the note that has been put out by Riya Chakrabarti's legal team. For the moment, let me go across to Prabhakar Kumar, who's tracked the story from Patna for us. Prabhakar, let me read out this portion of the note that has been put out by Riya's legal team, and then I want to ask you a question. Sheikh?
सुप्रीम कोर्ट का फैसला आया है जिसमें पीएम केयर फंड को एनडीआरएफ पे ट्रांसफर करने का एक प्ली हुआ है और ये बार बार विरोध किया गया था कि पीएम केयर्स को मिला दिया जाए। सुप्रीम कोर्ट ने लंबी बहस सुनी थी, उसमें कई ऐसे वकील लोग भी थे जो प्रामाणिक रूप से मोदी सरकार के कई विरोध के केस करते रहते हैं, ये उनका विवेक है। आज सुप्रीम कोर्ट ने अपने रिजर्व जजमेंट को सुनाया है और मैं इसके एक पैराग्राफ को पढ़ना चाहता हूं। There is no statutory prohibition on contributions made to NDRF, and the contribution to PM Care Fund are voluntary. Funds collected by PM Care Fund are entirely different, and these funds are funds of charitable trust. This fund need not be transferred. हमने इसको डिस्कस कर दिया। बाकी जजमेंट विस्तार की बात है, उसमें नहीं जाऊंगा। एक बहुत महत्वपूर्ण बात जानना चाहिए कि पीएम केयर फंड से अब तक 3,100 करोड़ रुपए दिए गए हैं कोरोना की लड़ाई में, जिसमें 2,000 करोड़ सिर्फ वेंटिलेटर के लिए दिए गए। और आज देश को बताते हुए आप सबों के माध्यम से प्रसन्नता होती है कि 50,000 वेंटिलेटर पीएम केयर फंड के द्वारा दिए गए पैसे से उपलब्ध कराए गए हैं, जो आजादी के बाद के आज तक के इतिहास के हाईएस्ट है। The 50,000 ventilators provided to take care of emergency needs of corona patients is the highest since independence as far as ventilator provisions are concerned. लगभग 1,000 करोड़ दिए गए हैं राज्यों को
जो हमारे प्रवासी मजदूर आए उनकी व्यवस्था करने के लिए, और लगभग 100 करोड़ रुपए दिए गए हैं कोरोना के खिलाफ वैक्सीन के अनुसंधान में मदद के लिए। तो 3100 करोड़ की बड़ी राशि कोरोना की लड़ाई के लिए दी गई है। हमारे पार्टी के मंच से आपको बताया गया है और मीडिया में भी आया है कि किस तरह डॉक्टर मनमोहन सिंह की सरकार के समय राजीव गांधी फाउंडेशन को एनडीआरएफ से पैसे दिए गए थे। आज मैं उसको दोहराऊंगा नहीं। और आपने ये भी सुना होगा कैसे 100 करोड़ रुपया बजट के प्रोविजन में भी किया गया था राजीव गांधी फाउंडेशन के लिए। राजीव गांधी फाउंडेशन एक फैमिली फाउंडेशन था, आपको पता है। और आपने ये भी सुना होगा कि राजीव गांधी फाउंडेशन को चीन के एम्बेसी से और चीन की कम्युनिस्ट पार्टी से ही मदद मिली थी। ये चर्चा यहां से हमारे प्रवक्ता मित्र कई बार कर चुके हैं। और आपको ये भी मालूम होगा कि राजीव गांधी फाउंडेशन ने जो अपनी रिपोर्ट बनाई थी, उस रिपोर्ट में ये भी कहा था कि भारत चीन के रिश्तों को सुधारने के लिए भारत का बाजार चीन के लिए खोलना जरूरी है। और आपको ये भी मालूम होगा कि राजीव गांधी फाउंडेशन ने जो अपनी रिपोर्ट बनाई थी, उस रिपोर्ट में ये भी कहा था कि भारत चीन के रिश्तों को सुधारने के लिए भारत का बाजार चीन के लिए खोलना जरूरी है। You would recall that on behalf of the party, we have shown the report of the Rajiv Gandhi Foundation, whereby a special study was done, which inter alia recommended that Indian markets needs to be opened for Chinese products to make the relationship more stronger. राजीव गांधी फाउंडेशन को कहां से किससे क्या क्या मदद मिली है, ये आप सभी जानते हैं। एक बात तो मुझे आपको बताना है जो समझना बहुत जरूरी है कि जो पीएम केयर फंड है, ये एक रजिस्टर्ड पब्लिक ट्रस्ट है, रजिस्टर्ड पब्लिक ट्रस्ट। और जो आपके प्राइम मिनिस्टर नेशनल रिलीफ फंड है, जिसे कहते हैं PMNRF, ये 1948 में बनाया गया था by an oral observation of the then prime minister. ये PMNRF 1948 में बना था। ये जो हमारे रिफ्यूजी आ रहे थे पाकिस्तान से, उनकी आवश्यकताओं के लिए, या कोई कभी अर्थक्वेक आ जाए या बाकी आ जाए, इसके लिए। जबकि ये जो पीएम केयर्स है, ये एक रजिस्टर्ड पब्लिक ट्रस्ट है, जिसके प्रधानमंत्री अध्यक्ष हैं, और ये कोविड ऐसी इमरजेंसियों के लिए बनाए। ये बात समझना, दोनों में बहुत अंतर है। अब मुझे आपको बताते हुए कभी कभी आश्चर्य भी लगता है, मैं नाम तो नहीं लूंगा। ये जो PMNRF है, इसके एक कांग्रेस के बहुत सक्रिय सीए जो मंत्री भी थे, थ्रू आउट सीए वही रहे। ये भी आप समझ सकते हैं, और इससे अधिक बोलने की आवश्यकता नहीं। ट्रांसपेरेंसी इज रिट लार्ज इन द PM केयर्स फंड, both in terms of legal requirement and both in terms of transparent management of funds received on a voluntary basis. इसमें पूरे फंड वॉलंटरी रूप से आते हैं। तो आज हमारी सरकार के 6 साल पूरे हो गए, हम 7वें साल में हैं, और बहुत गर्व के साथ हम कहना चाहते हैं, 6 साल से मैं अपनी सरकार में मंत्री हूं, प्रधानमंत्री के निर्देश पर। हमारी सरकार ईमानदारी से काम करती है, और अभी तक एक भी भ्रष्टाचार के आरोप लगाने की किसी को तथ्यों के साथ हिम्मत नहीं। और बाकी कुछ लोग अपना बोलते रहते हैं, तो छोड़िए, उसके बारे में क्या कहना। नरेंद्र मोदी की सरकार ईमानदारी से काम करती है, इसे जनता का आशीर्वाद मिलता है, और वही ईमानदारी PM केयर फंड में भी दिखाई पड़ती है।
আপনারা কে হে সানফিস্ট মমস ম্যাজিকে আনিছে নতুন ডাবল প্রোটেকশন প্যাক
दुआ तो हुई है। और जिस तरह से भारत ने प्रधानमंत्री की अगुवाई में कोरोना के खिलाफ जंग लड़ी है, तो जहां लोग एफ्लिक्टेड हुए हैं तो रिकवरी रेट है 70% प्लस। इस बात को समझा जाए। कोई भी मृत्यु होती है तो दुर्भाग्यपूर्ण है, लेकिन हमारा जो मृत्यु दर है वो भी तुलनात्मक दृष्टिकोण से बहुत कम है अगर आप पूरे मृत्यु दर को देखेंगे। राहुल गांधी ने एक पहले दिन से देश की एकता को कमजोर करने की कोशिश की है कोरोना के खिलाफ लड़ाई में। याद करिए, प्रधानमंत्री जी ने कहा था कि देश के डॉक्टर, नर्सेस, पैरामेडिक स्टाफ, एम्बुलेंस ड्राइवर, सफाई कर्मचारी, पुलिस, मीडिया, इनके पक्ष में ताली बजाया जाए। याद होगा आपको, हेलीकॉप्टर से फूल बरसाए गए नर्सेस पर, डॉक्टर्स पर। राहुल गांधी ने मजाक बनाया उसके, ताली बजाने से क्या होगा। और आज पूरी दुनिया डॉक्टरों के पक्ष में सम्मान से ताली बजा रही है, जिसकी शुरुआत प्रधानमंत्री जी ने की। जब लॉकडाउन आया तो राहुल गांधी ने क्या कहा, लॉकडाउन से क्या होगा। उनकी बात उनकी सरकार चाहे पंजाब में है या राजस्थान में नहीं सुनती थी। वहां तो लॉकडाउन पहले ही कर दिया गया था, कर्फ्यू भी किया गया था। जब प्रधानमंत्री जी ने कहा कि पूरा देश में आशा के लिए दिया जलाए, मोमबत्ती जलाए, तो पूरे भारत में दिया जलाए, आशा का दिया, संघर्ष, संकल्प और ऊर्जा का दिया। गरीब ने अपनी झोपड़ी में भी जलाया। राहुल गांधी ने क्या कहा, यह दिया जलाने से क्या होगा। जो आईसीएमआर काम कर रहा था उस पर भी टिप्पणी करना। अब मैं बार बार उन चीजों को मैं रिपीट नहीं करूंगा। और पीएम केयर फंड पर भी हमला करना। तो राहुल गांधी ने एक भी कसर नहीं छोड़ी और कांग्रेस पार्टी ने, जो कोरोना के खिलाफ लड़ाई को कमजोर किया जाए, राष्ट्रीय संकल्प। I regret to say, in view of the conduct of Mr. Rahul Gandhi, right from day one, he never spared any opportunity to weaken the national resolve in the fight against corona. और ये बात मैं आपसे इसलिए कहना चाहता हूं कि बहुत सी पार्टियां जो कांग्रेस पार्टी के साथ हैं, उनके नेताओं ने भी डॉक्टर, नर्सेस के पक्ष में ताली बजाई और दीपक भी जलाया था। तो आज जब पीएम केयर्स फंड पर यह फैसला आया है, तो उनके द्वारा एक प्रायोजित षड्यंत्र का सुप्रीम कोर्ट ने बिल्कुल निरस्त किया उसको। और ये बिल्कुल ट्रांसपेरेंट फंड है पीएम केयर्स का। इसकी ईमानदारी से कार्रवाई हो रही है, पारदर्शी तरीके से इसका निवेश हो रहा है। मैंने बताया, रिपीट करूंगा, 2000 करोड़, लगभग 50,000 करोड़ वेंटिलेटर खरीदने के लिए, 1000 करोड़ मजदूरों के लिए, उनके पुनर्वास के लिए, और 100 करोड़ वैक्सीन की खोज में मदद करने के लिए। तो जो वॉलंटरी बेसिस पर पीएम केयर्स में लोग डोनेशन दे रहे हैं अपनी इच्छा से, उसका सदुपयोग हो रहा है। और जब सुप्रीम कोर्ट ने मुहर लगाई है, तो मुझे लगा कि आज पार्टी की ओर से हम ये चर्चा करें, आपको बताएं, और किस तरह से कांग्रेस पार्टी और विशेष रूप से राहुल गांधी के द्वारा राष्ट्रीय संकल्प को कमजोर करने की कोशिश की गई, जो कोरोना समय सबसे अधिक आवश्यक थी, उसकी भी चर्चा करना जरूरी है। That's all from my side. Open to questions. उस पर मैं बाद में बात करूंगा। इस पर पीएम केयर्स फंड पर कुछ पूछना है किसी को? देखिए, मैं एक बात आपसे साफ साफ कहूंगा, इस देश में आजकल दो प्रकार के लोग हैं। एक जो आरटीआई के बड़े समर्थक थे कि मंत्री के रूप में मैं फाइल में क्या लिखता हूं ये भी उनको मिलना चाहिए, आजकल वो राइट ऑफ प्राइवेसी के भी बड़े समर्थक हो गए। हाँ, ये दोनों कहानी चलती है। रविंद्र जी, कोई समस्या नहीं, ऑडिट होगा, जो वेबसाइट पर है सब कुछ। मैंने कितना खर्चा किया है पूरा बता दिया आपको। वेबसाइट पर जाइए, ऑडिट भी होगा, तो आपको वहां पर बाकी राशि क्या हुई मिलेगी। ये नरेंद्र मोदी की सरकार है। यहाँ पब्लिक ट्रस्ट बना है, रजिस्टर्ड हुआ है, कौन कौन ट्रस्टी है ये भी पता है, बाकायदे ऑडिट होगा और देश को बताया जाएगा, सब कुछ वेबसाइट पर है। यहाँ ये नहीं होता है कि बजट में राजीव गांधी फंड फाउंडेशन के लिए 100 करोड़ और बाकी एनडीआरएफ के फंड से फाउंडेशन, ऐसा नहीं होता है। और कुछ देखिए, आज का विषय यही है। अगर आपको तो कोई सवाल नहीं पूछना है तो धन्यवाद। देखिए, एक मिनट रुकिए, बस मैं एक अपने से बोल देता हूं, देन आई विल नॉट टेक एनी क्वेश्चन। अच्छा, सब अपने सवाल दे दीजिए, मैं बस एक जवाब दूंगा। सब लोग एक एक करके सवाल दे दीजिए, फिर एक सवाल जवाब। शॉर्ट क्वेश्चन प्लीज। थैंक यू। चलिए, आप और कोई सवाल? चलिए, धन्यवाद। और कोई सवाल? रवि अमित जी, चलो धन्यवाद। राहुल, देखिए इसके दो विषय। पहला विषय है जो एक वॉल स्ट्रीट जर्नल में चीजें छपी, वो विषय फेसबुक अपना तय करेगी, ये उनकी पॉलिसी सिस्टम है। कल मैंने राहुल गांधी के ट्वीट का जवाब ट्वीट पर दिया है, जिसको आपने देखा है, आपने चलाया। वो पार्टी की ओर से प्रामाणिक स्टैंड आपके सामने है। जहां तक बाकी सवाल है, पार्टी के आईटी विभाग की ओर से बताया गया किस तरह 700 पेजेस जो बीजेपी के समर्थक के थे उसको हटा दिए गए फेसबुक के उस पर, आपको मालूम है। तो ये भी एक सच्चाई है। बाकी इसके बारे में पार्टी के वरिष्ठ प्रवक्ता लोग बैठे हैं, आगे आपको बताएंगे। लेकिन मैं आपसे एक बात अवश्य कहूंगा, मैं किसी प्लेटफॉर्म का नाम नहीं लूंगा। अगर प्लेटफॉर्म पब्लिक प्लेटफॉर्म है,
Hello, Mrs. Yogi.
Yes,
Hello.
yes, sir.
Can you see me?
Yes,
Yeah, with a mask. I can see you without a mask
yes.
because you do not have distancing and COVID-19.
Yeah, it is very, the COVID is, means the, it is declining in our Sweden. And moreover, the population of Sweden is less than that of Mumbai. So automatically distancing is followed.
Yes, yes, that is true. But even then, for example, in US, see, it's a huge place. This thing is not much. Population is not that dense like in Mumbai or or India. But even then, they don't believe in mask. Mr. Trump. Okay, so we'll listen to you. Because you are a lady, it will be chaired by a lady. Or this session, it will be chaired by the principal of Jorhat Engineering College. She happens to be the first engineer of that town, Jorhat, which is famous for tea gardens. So we have chosen special people for special sessions. Okay? Yeah. So we'll listen to you.
Namaskar. I welcome all the participants, invited speaker, and oral presenter and the dignitary to this session. And this session will be shared by Professor Rita Sharma. Professor Rita Sharma, she is the principal of Jorhat Engineering College, one of the oldest college in Assam, from Upper Assam. She is by education, she is a mechanical engineer. So I will request Professor Rita Sharma Madam to start the session at 2 o'clock. Right now, I think 1:56. After 4 minutes, she will start the session. So I welcome Dr. Yogi and Dr. Anil Bhardas also. Professor Rita Madam, honey paisane? I think you are. Madam, our audio connect hoise na, please check once. That is shown, but Professor Rita Madam. Professor Rita Madam. Professor Rita Madam. Hello. Please check once. Rita Madam connection. Please check once the connection of Professor Rita Madam. Professor Rita Madam. So maybe she may be having some problem in connection. So I would like to help Professor Rita Sharma. So I welcome to these sessions all the participants and invited speaker. The first talk is to be delivered by Dr. Rutumbara Yogi. She is from Sweden, and the topic is the energy efficient Detroit RF power stations for ESS spoke cavities. So I would like to read her small CV. Dr. Yogi received PhD degree in 1999 from University of Pune. The PhD work was based on use of microstrip ring resonator as a moisture sensor. She worked in SEMAR and IPR in India till 2011. After that, she has worked at FREIA in Sweden as a team leader for higher power RF till 2013. At present, she is working at European Spiralation Source ESS at Lund, Sweden. I request Professor Dr. Yogi to start the session. Thank you. Yogi, please.
Thank you very much for the introduction, and thank you, Professor Bora, for this opportunity. I will start sharing the presentation. Is it visible?
Yes, it is visible, please.
Thank you very much. So today I will talk about energy efficient tetrode RF power station for ESS spoke cavities. So first, what is ESS? ESS is European spallation source. Spallation is the process that releases neutrons from the target nuclei. When this happens, when an accelerated beam of protons is made incident on the targets, neutrons are emitted by process of spallation. The energy of these neutrons is controlled by a modulator, and then it is given to the samples. And then further, the spectrum of neutrons is detected by the instruments and to study the material properties of the samples which are exposed. So ESS will be the world's strongest neutron source. Here, the y-axis shows the neutron flux, and there are different facilities. Different neutron sources are shown here. The red color neutron sources are accelerator driven neutron sources, and blue color are reactor sources. So if we look at this graph, then the flux that will be produced by ESS will be 4 times more than the flux which is available today. So it is going to be the world's strongest neutron source after its installation. So let us look at some numbers for ESS. Its construction cost is 1.8 billion euros. Then what makes it more powerful? It is the accelerator, because ESS will have world's most powerful particle accelerator, delivering 5 megawatt average power to the target. It will have 15 experimental stations. It is when the instruments are 20 times more sensitive than today's best at 2 megawatt. There will be 800 experiments carried out per year, and it will be first science for users will be carried out in 2023. There are 13 ERIC member nations. ERIC is European Research Infrastructure Corporation. So basically, if we just briefly look at the milestones, European design of ESS was completed in 2003. Then construction started on greenfield site in 2014. And now we are here. Now we are here, where that means construction is going on and initial operation phase is also started. The construction will be completed in 2025, and then ESS will operate for another 40 years. So this strongest superconducting proton accelerator is mainly in 2 parts. We have accelerator gallery, which consists of RF systems, means amplifiers, high voltage power converters, RF distribution, low level RF systems, interlock systems, racks, etc. And then there is an accelerator tunnel, which is 5 meters below the ground level. It consists of cavities, RF distribution, phase reference line, interlock systems, etc. These proton beam is made incident on the tungsten target, which is with innovative flat moderator design, and neutrons are given for different experiments using these beam lines. So if we look at schematic for ESS accelerator, then this part, that is spoke, medium beta and high beta, it is superconducting, and this part RFQ, MEBIT and DTL is warm cavities. So basically it is long pulse superconducting LINAC. Peak beam current is 62.5 milliampere. Beam pulse width 2.86 millisecond. Pulse repetition rate is 14 Hertz. Peak proton beam power to the target is 125 megawatt. Average proton beam power to the target is 5 megawatt. Now, what is this 5 megawatt? At 5 megawatt, one beam pulse, it has same energy as 7.2 kg shot traveling at 1100 km per hour. It has same energy as a 1000 kg car traveling at 96 km per hour. And also it happens 14 times per second. So what makes it so strong is the power delivered to the proton beam. Now let us look at the amplifier profile. Warm LINAC, that is RFQ, has one cavity, DTL has 5 cavities. Klystron, which are 3 megawatt peak, they power these cavities at 352 megahertz. Then next part is the spoke LINAC. 26 spoke cavities, which are resonant, are at 352 megahertz, are powered by a dual tetrode based power source, delivering 400, which is with output power of the source 400 kilowatt peak. Then we have 36 medium beta cavities and 84 high beta cavities. Both are resonant at 704 megahertz. They are powered by 1.5 megawatt peak klystron. So now today we are talking about amplifier for the spoke section. So as we have seen, spoke section consists of 26 cavities, and power profile, that is power coupled to the beam, is as shown here. The power varies from about 260 kilowatt to 330 kilowatt. This is the step model of the spoke cavity, and one spoke cryo module has 2 such spoke cavities. This was in-kind contribution by France. So what are the spoke amplifier specifications? Considering design parameters like power coupled to the beam in spoke section, then LLRF overhead to keep cavity at resonance. This LLRF overhead differs based on amplifier technology. In the next slide, we will see why it is different based on amplifier technology. Then there will be some losses in the RF distribution systems, so we have to consider loss overhead, etc. So the spoke amplifier specifications are frequency 352.21 megahertz, peak power 400 kilowatt, RF pulse length 3.5 millisecond, pulse repetition rate 14 hertz, average power is 20 kilowatt, and 1 dB bandwidth of the amplifier should be more than 1 megahertz. This is for the tuning purpose. Number of spoke cavities are 26, and our requirement is that 1 amplifier per cavity. So number of spoke amplifiers are 26. Amplifier were not existing at these ESS specifications. And reliability of spoke amplifier is very important because proton beam will be lost if we lose more than 1 spoke amplifier. Hence, choice of amplifier technology and design was really important. Now, all the amplifier technologies are possible at 352 megahertz, as you see. Transistors means solid state is possible. Graded tubes like tetrodes, IoT is possible, and it is the low frequency for klystron, but it is also possible. Then what technology to choose? The single IoT delivering 400 kilowatt doesn't exist even today. So we have to combine 4 IoTs of 100 kilowatt to deliver 400 kilowatt power. Then footprint becomes 3.8 meter by 3.8 meter. So it doesn't satisfy our ESS specs requirements. So it was not considered. Then solid state technology. A single LDMOS chip can deliver up to 2 kilowatt RF output. And then combination and recombination of RF modules are required to generate 400 kilowatt peak. It also doesn't satisfy ESS space requirements, so it wasn't considered. But the solid state technology is advancing very fast. So maybe after few years, it is possible to satisfy these ESS space requirements. Okay, then will klystrons be better than tetrodes? Let us see. Now, for this green curve indicates power coupled to the beam. Now we have to calculate the amplifier power. If we look at gain curve of the klystron, it saturates here. So even if we vary input power, output power will not vary, it will be constant. At this point, Klystron efficiency is maximum at saturation 67 to 70%. But we need to vary input power because reactive beam loading, Lorentz force detuning, variation in loaded Q, beam current fluctuations, variations in cavity parameters. So we have to vary this power, input power, to keep cavity at resonance with correct phase and correct amplitude. So we cannot operate Klystron here at saturation, but we need to back it off from saturation by about 25%. And so this is the operating power level. Here, amplifier Klystron efficiency reduces by about 10%, that is 60%. This curve represents the gain curve for graded tubes like IoT or tetrode. So for tetrode, gain is lower, but it's linear. There is no saturation. And hence for tetrode, we have same efficiency everywhere, and low level RF overhead also is less, 15%. We don't see saturation in this curve. So consider maximum power coupled to the beam is 330 kilowatt. So for tetrode based amplifier, the power requirement of amplifier will be 400 kilowatt, and that for Klystron will be 430 kilowatt. So here difference in power is about 6%. So requirement of power is higher for Klystron. This is one negative point of the Klystron. Then if we compare tetrode RF power station with Klystron RF power station, these are the schematics for both. Here, one tetrode cannot produce 400 kilowatt, so combining is needed. One tetrode can produce at the most 200 kilowatt. But whereas one Klystron can deliver straightway 450 kilowatt, combining not needed. The tetrode size is very small, 11.4 centimeter in diameter, and height is 22.8 centimeter. Whereas Klystron is 1 meter by 1 meter cross-sectional area, and height is 3.5 meters. Weight of tetrode is 7.2 kg. Weight of Klystron is few tons. We can replace tetrode very easily as it is size is small. There are fixtures made by Thales, so we can replace it very easily, less than 30 minutes. Here, time to replace Klystron is few hours. Here, one disadvantage for tetrode is that its gain is lower, as we have seen earlier, 15 dB. So it needs a preamplifier to deliver power about 7 kilowatt. For Klystron, gain is very high, 37 dB. So very small pre-driver of 70 watt is sufficient. Now let us consider efficiency and schedule. For tetrode RF power station, high voltage power supply with voltage of 18 kV and 44 ampere powering two tetrodes is sufficient. Whereas for high voltage power supply for Klystron is a modulator which is pulsed. It is 70 kV voltage and delivering about 10 amperes. For tetrode, we pulse it via RF drive. It reduces wall plug power and improves wall plug to RF efficiency. Whereas for Klystron, we have to pulse, in addition to RF pulse, we have to pulse modulator also. And so there are extra losses due to this pulsing of modulator. These are the modulator losses. In addition, we are backing it off from saturation, so there are extra losses here also. So it reduces wall plug to RF efficiency. Then the tetrode RF power station was developed by us at Freja, which is test stand of ESS in Uppsala, Sweden. This Klystron RF power station needs to be developed it was needed to be developed. The prototyping and testing needed about 12 to 18 months, and then thorough testing for reliability. So this is also one of the limitation. Then another thing was that we have limited number of klystron suppliers around the world. So we have, as we have seen, spoke LANAC is next to medium beta LANAC. For medium beta LANAC, we have chosen klystron as amplifier. So these suppliers will be already loaded with demand for developing medium beta klystrons, which are 36 in number, and hence it will be extra burden for these klystron suppliers. Then very important thing for these spoke amplifier was reliability, because if we lose more than one cavity, then beam cannot progress, it has to stop. So reliability of the spoke amplifier can be tested at Freya, which is test stand of ESS. It was extremely important. Then we also considered operating costs for 25 years of operation. Okay, we know the RF power that we need. Using data from the suppliers, we calculated beam voltage variation of beam voltage with the saturated power. We calculated beam current, and then efficiency is RF output by DC input. So we predicted the efficiency. So predicted efficiencies varies from about 48% to 50% for klystrons. And for tetrodes, it is the experimentally tested high voltage efficiency was 67%. So operational cost of klystrons was more by few million euros. Then we also considered replacement costs for 25 years of operation. For 25 years of operation, we are going to operate for 6,000 hours per year. So it becomes 150,000 hours. For tetrode, we have considered lifetime of about 20,000 hours. It shows graceful degradation. So planned maintenance can improve the reliability. For klystron lifetime, we have considered 70,000 hours. If cost of tetrode is X kilo euros, then cost of klystron is more than 15 times X. And number of replacement for tetrodes for these 150,000 hours will be about 14, whereas for this it is about 2. The cost of replacement for tetrodes for klystrons is more by few million euros. Then the experimental operational data from CERN shows that if we operate tetrode carefully, then even average lifetime of 20,000 hours to 32,000 hours is also possible. So we have to plan operation of tetrode very carefully. So due to all these reasons, we have selected tetrode as baseline technology for ESS spoke LINAC. Considering capital cost and replacement cost of tetrode solution was cheapest. Considering operational cost, tetrode solution is efficient and low operation cost. Initial cost of ESS is 1.8 billion euros. Tetrode solution comes out to be cheaper by 0.2 to 0.3% of initial cost. Tetrode has lowest technical and lowest schedule risk. And then we work to lower the capital cost and improve reliability. So these are the tetrodes and dichrodes which are available from the industry. There were two options, either to use TH781, which was tested for 200 kilowatt CW, use at lower frequency, use this tube at ESS specification with gain 30 dB and efficiency 55%, or to use TH595, which is tested at high frequency but low pulse width of 100 microsecond. Operate it at 200 kilowatt and then combine two tetrodes to produce 400 kilowatt. Here, if high voltage efficiency is 67%. So again, if we convert it into cost, then cost difference for 25 years will be more than 1 million euros if we choose TH595. So it was selected. Okay, these are the test results for the tetrode amplifier. So TH595 is selected, and then we see that it can produce 200 kilowatt power output with 67% efficiency, and yeah, and it is constant over all the power range. So high level design of spoke RF power station was done. It was done based on reliability, ease of operation, reduction of downtime, cost optimization. The main considerations were, should we use only one preamplifier or two preamplifiers? What should be topology of preamplifier? Tetrode, triode, or solid state? Single anode power supply or two anode power supplies? Protection of the tube, should it be a series switch or a crowbar? And how to balance the two tetrodes so that we have minimum power in the reject load. So this is the basic of the tetrode amplifier. This is the high voltage power supply. This is the in the case of event or of arc in the tetrode, we need two tube protection, because otherwise this anode power supply energy will be dumped in the tetrode. So either it can be a series switch which opens and then anode power supply is isolated from the tetrode, or a crowbar. In this case, the power supply discharges through the short. Okay. Then Thales has developed TH595A improved version, in which screen grid dissipation is improved as compared to TH595. If we have two preamplifiers, that advantage, then we need this attenuator and phase shifter to minimize power going to the reject load in spite of differences between the two tetrodes. Cost of this design was 1.7 euro per watt. We can also have one preamplifier and then which provides input to the two tetrodes. In this case, phase shifter is required and it is in 10 kilowatt peak region, hence there will be losses. Then tetrode tubes, if there is different aging of the tetrode tubes, then there will be amplitude imbalance and then we will have power going to the load. In this case, for preamplifier, solid state amplifier or tetrode, both options are possible. If we have solid state as preamplifier, then we get cost of 1.58 euro per watt. For tetrodes, for tetrodes, we had different options also. We can use the same tube at 220 kilowatt. It will be as reliable as solid state amplifier. We can also use the same anode power supply. But here, even though the capital cost is slightly lower, there will be replacement cost due to limited lifetime, because this tube will again need some preamplifier. Even if we use TH595 at 20 kilowatt, it will need some preamplifier. Here cost was lower, 1.49 euro per watt. Then tube protection, as we have seen, series switch or a crowbar. So in case of, if we select crowbar, then short circuits in the anode power supply in the event of arc discharges capacitor bank which is present in the power supply each time, and then we miss few next pulses, whereas reliability is very important for us, and also lifetime of the anode power supply is affected. But whereas series switch opens, and so anode power supply and tetrode are isolated, capacitor is not discharged, and we are ready for the next pulse. So for cost reduction and improved reliability, we have selected a single anode power supply and a single series switch to protect as a protection. single series switch was a new development. It will 50 ampere at 18 kV. This we have developed and tested. So this is basically design of RF power station for spoke Linac. 2 solid state amplifiers giving input to the TH595A, which is combined using hybrid combiner to produce 400 kilowatt. And with further optimization, cost can also be, means even cost of 1.38 euro per watt is possible, was possible, I think. Okay, finally, this is the RF power station, which is at ESS site now. It is just developed last week, delivered last week. It is delivered as a part of Italian in-kind contribution towards ESS. The detailed design of RFPS is done by ESS and Electra, which is Italian company. And this is the front side of RFPS. These are the 2 cabinets in which tetrodes are mounted. Here is the hybrid combiner by which the outputs are combined. And here you can see it is delivered to the load. This is ferrite load. And at present it is being tested at test stand 3 in ESS. So thank you. I hope I haven't taken more time. Afterwards, I had to become slightly faster. So any questions?
I think we can see the question. We'll read it out for you and then you can reply. There is one question from Kamal Talukdar.
Okay.
And the question is, after combining all advantages and disadvantages of tetrode and klystron amplifier, which amplifier should be used / advantage here? I think you already said that you will use tetrode.
Yeah. Yes. Yeah. And
but I have a question also, along with that. You are talking of 25 years of operation. That means you need to maintain this system for 25 years. And therefore, you need the same technology to be alive in Thales for your tetrodes for next 25 years.
Yes.
And at least my experience says that even Thales, we have tubes we had in IPR. What we have seen that, years, they do change some design of some components within the tetrode. So then I'm not very sure if it will live for 25 years, your design. What is your comment?
Yeah, this is a very good comment. Actually, even I have shown here that they have improved our selected tetrode for screen grid losses. It is better. So now it is, instead of TH595, it is TH595A, but all the interfaces, external geometry is the same. And then right now we don't have any direct contact with Thales because it is in-kind contribution. But once now when it is delivered to ESS, we have the ownership, and then we are going to talk to Thales that if they stop, means earlier we had talked when we had selected this, that if they stop this production, then they should give us all the documentation so that we can go to another company with their documentation and can produce the same tube. And if they want to improve, and if it is advantageous for us, then it is good. Means if they improve something like they improve lifetime or efficiency, then it is good for us.
That is true. Efficiency is good and all, but if in the process the whole tube physically changes, then the mounting, etc., will have to be changed, and everything comes into the picture.
But
unless you keep it as a mandatory that the input and the output has to be same so that it matches on either side,
Yes.
and in between you can do whatever you want.
Yes. And this thallus, the cavity is also developed by Thales. So it is their good business actually. So
Yeah.
at least now they have agreed to everything. Now let us see what future will tell us now. What is
Yes,
their
yes. Okay, fine. I don't have any other question. Don't have any other question on this side. So I think
Thank you, Dr. Yogi, for your nice presentations.
Thank you.
And we're looking forward for your cooperation with this university. And I now request our chairman of the session, if she is in the line, Professor Rita Madam. Professor
Hello.
Rita Madam. Hello.
Yes. Am I audible?
Yeah, Madam, you are audible now. Ma'am, you can continue your session.
Yes.
Yeah.
Second, I should invite the second participant or what? Hello.
Yeah, is Dr. Yeah, I'll request Professor Dhiraj Bora sir to introduce Dr. Anil Varadas. He has been working with Professor Dhiraj Bora.
well, Anil, as usual, has not sent his CV so that somebody else could read it out and then he would be introduced. But since it is not there, I will just tell that he is a mechanical engineer with an MTech degree who joined IPR in the beginning of 2000, and he was working with me for some years. He is an excellent designer, and he finally joined our ITER India team to build a design and keep track of the building of the cryostat, which is the biggest part of the ITER experimental reactor which is being built. He was one of the main guys, and he's still main guys. He's stationed in Cadarache and taking care yesterday what Mike Walsh had shown, the cap. So they have started putting the things in place from bottom. So he will tell us all these intricacies of building these kind of extremely huge mechanical components with extreme tolerances in millimeters. They talk of, 5 centimeter minimum thickness of stainless steel with an accuracy of millimeters over a height of, 10 meters and 15 meters like that. So all that will be told by Anil. So he's a mechanical engineer by profession, and now he's a mechanical engineering manager managing the show with the Europeans there in Cadarache, France.
Thank you, sir. Over to Chairman, Professor Rita.
Thank you, sir, giving my introduction, and thanks for inviting me for this session, giving the overview of the ITER cryostat, which is the one of the largest vacuum vessel of the world. And it's proud that India is building such a massive vessel for ITER project. So I would like to give the complete overview of the ITER cryostat and from the design, and then later on in the manufacturing, what we have done till now, and what is the future of this machine component for the ITER. Okay, so I would like to share my screen. Just a minute. Okay, so first I would like to give general overview of the ITER crash state. It is the main component of ITER machine, which encloses the complete ITER machine. You could see the different components of the ITER machine. One of the inner part was the vacuum vessel with the in-vessel components, and then you are having the magnets, toroidal and the poroidal magnets, and later on the water cooling, thermal shield, and everything. But cryostat house all of the component inside and gives the penetration and access to the outer world, and it also provide the insulation to the superconducting magnet. So this is a biggest, I would like to say, biggest thermal freeze which could consist the ITER machine, full ITER machine. So it is the size is 29 meter diameter and height is nearly same, and it is made up with 4 major sections. Consist of a base section, which is the largest and the heaviest part of the ITER machine and also part of the cryostat. It is made up of austenitic steel 304 and 304L. And this is having a shell. You could see this is a perforated shell which provide the access to all its ITER system. And it is having 2 parts again, the lower cylinder and upper cylinder, and the top one is the top lid. So as it is made up of steel, so we have also different thicknesses in this. The main shell thickness is 50 mm, but the pedestal ring is having a parts thickness of 200 mm thickness, and it is having around 280 penetrations, which required to connect and to reach to the vacuum vessel. Also, due to the thermal displacements and also with the seismic events, we have to have the bellows, so which are connected with the building. So we are having around 85 rectangular bellows, and we could think of size is around 3 by 3 meters of a bellows. So this is also a one of its kind of rectangular bellows, and we are developing right now these bellows with the industry in ITER organization. And also we are having 6 torus cryopump housings which house the cryopump for the vacuum vessel. Again, this is part of India to provide this component, and vacuum technique in Bangalore is doing the manufacturing of this component. The complete cryostat is being manufactured by L&T. Next, so as I told that it provides the thermal insulation and for magnets and thermal shield, also provide the support to the ITER machine. It means it transfer the complete load of the ITER machine to the building, and the dead weight itself is 21 thousandths of a ton. So we could assume with the seismic load, thermal loads, so it is a huge amount of load is coming on the cryostat, and the design was a challenging task with considering all interfaces with all such systems which are coming on the cryostat. So typical parameters, as I told, 29 meters. Then the vacuum is 10⁻⁴ Pascal in end when we'll close the complete cryostat. Surface area is 3,400 meters square. Free volume is 8,500 meter cube. And you can see the typical weights. So the base section is 1,250 tons, and others are nearly varying from 400 to 700 tons. The design and manufacturing code is ASME section 8 division 2 with additional requirement which is needed for heater vacuum system. And also it is a quality class 1 component. We have to follow the protection important activities because this is a SIC component. Also there is a seismic class in heater organization. So we have to follow all the things and requirements for the design and manufacturing and later on the installation. So we have to have a nuclear traceability on each step from the design stage to the final manufacturing installation. So I would like to share first because as Professor Bora told that I am involved from the beginning. So after the design of this vessel in 2010, final design was done and later on we signed a PA with India and IO and then we transferred the scope of manufacturing to L&T and the contract was signed with L&T in 2012 and this is the one of the, I would say, the biggest contract under single contract of the Department of Atomic Energy. And I'm proud to say that I was the contract manager, contract RO for this, and I did all the required things, technical, also the finalizing the contract. So next is that how to manufacture this. So we have divided the manufacturing of cryostat in different stages, because it cannot be made up in single piece because it could not be installed, it could not be transported. So we divided it to 4 sections as already communicated. Later on, each section is divided in different sectors. And this is again due to the transportation limitation in India also and in France. And the maximum size of the component could not be 9 by 9 by 16 meters. So this is the maximum possible component size. And then we did a optimization to manufacturing and so have to have a maximum size to control the distortion requirements and also the welding due to the welding. So this is the plan. You could see the base section which is made up of around 18 sectors. The lower cylinder is made up of 12 sectors with 60 degree each, and upper cylinder which is also made up of 12 sectors, and again top lid is made with the 20 degree 18 sectors. So I will give you the brief of each from the beginning to end for manufacturing one by one and also convey the requirements. So before going to the factory, because from India's point of view, we have to build a workshop at ITER site, and we are the second building we constructed from India. It was a big challenge for us to build a building at foreign land and to design and building everything. So we did successfully and completed the building in 2014, which is having a 44 by 110 meters the width and length and 27 meter of a height with having a 200 ton crane capacity. It's a temperature controlled building. So because these components having a bigger size, so due to the thermal impact, we could have a difference on the dimension of the component. So we want to have a stable temperature in the building. So you could see that building is having 2 platforms. So we could make 2 sections sub-assembly because when we transfer this component, this has to be done at site. So we have to weld all these sectors in the ITER side in the building which we made, and then finally assembly need to be done in the tokamak pit. So you could see the path, the 2 sections parallelly planned to build. Then we have to transfer in the pit. So we are already in the very advanced stage right now, but I'm showing a picture of a beginning in 2012 and 13. So this is the 3D view of the base section. You could see the tier 1 and tier 2. This is the again massive structure which is having a single 60 degrees, having around 125 tons of stainless steel, and this is a cylinder of a 20-meter diameter. This is a main shell, and the sandwich is also a 600 mm of height with a ribbed structure and maintaining a profile. You could see this the bottom part, which is a requirement, right, 90 mm across the 20-meter diameter. So if you could go in the course, it is a 1% of a diameter, and we have to achieve with a 100th of the profile tolerance or the flatness. So it was a big task for us. L&T did lot of validations, mock-ups for manufacturing this. So you could see the sandwich, how it has been made of. So much welding on the rib structure, and this has resulting a very high distortions. So this has been made like a turning them after one sequential welding, and then turning back and again doing this is a very iterative exercise, and it was a big challenge for any of the industry in the world, and it was successfully done by L&T finally. So you could see how it has been manufactured. It is a L&T factory picture. So later on in 2015, because the manufacturing started in 2014, and we shipped the first component in 2015 and had a flag of ceremony in L&T. So later on in France, we started to manufacture and sub-assemble here. So you could see the complete full circle of this tier 2, this sandwich structure with the fit up. You could see only fit up without the weld, and then later on welding has been done. This is the single part which we received in the beginning. So this is the sequence how we made this. This is the frame, and then we have placed all the sectors one by one and did a weld fit up. You could see the full circle. You could see the another part of this is the tier 2, and this is a pedestal ring, and this is the heaviest part, which is having a 200 mm thickness. This is 80 and 120 mm thickness plates. And we are also proud to say that this all material is manufactured first time in India for such thickness by L&T in their forging facility at Hazira. So again, I would like to share how sequence has been done after this first part. Then we assembled the top part, and then one by one in 2017. Then you could see how difficult part for handling also. Material handling was also very challenging for each stage, and along with the tolerances and the manufacturing requirement. And on the site, because on the factory we could do the volumetric examination by RT, but on site due to the French regulations, co-activities issues we are having, so we have to do UT for this. And for UT of the austenitic steel is very difficult because it's a higher grain size, and which lead to a wrong signals of the weld defects. So you could get a wrong results, and for that we did a lot of validations to really characterize the weld defects rather than a wrong signal. So after doing the assembly, we have to do the machining to achieve the final tolerances which needed for the assembly of the TF coils. So this is the final section which we manufactured and assembled in July 2020. So this is handed over to IO from India in July 2020, and Dr. Kakodkar was there to hand over this component from India to ITER organization. And I would like to convey that again the tolerances were very stringent for this, and we achieved this except one NCR on the floor, the minor one NCR on the floor, which was accepted as is. Otherwise, we achieved everything as per the requirement. Next component was manufactured is lower cylinder, which is again put into the plates, rolling, and then stiffeners, welding, and doing the welding. This is again in the L&T factory. It's a massive components having a 5-meter height, and the diameter itself is 30 meter nearly, and doing welding and controlling the weld distortion was again challenged. Again, it has been done with lot of mock-ups and validations. And we use mainly the TIG welding on this manufacturing. So later on in 2017, we received the components and started manufacturing and sub-assembly of the lower cylinder on site. So it was again completed in Feb 2019 successfully from India. So, and then later on we cocooned it, because this is again necessary because the ITER schedule was delayed, but from India we delivered all these components on time. But we have to store them for years, and that is also a very difficult task to store such austenitic steel in a controlled environment. So we store them in a cocooning. It's a special material, and also controlling the humidity and temperature in this storage. So later on you could see the another part which was built is the lower upper cylinder. Same process as was done for the lower cylinder. So it was started again assembly in beginning of 2019, and by learning lessons we built it within 9 months and completed in 2020, and already stored both of the components on site. Next component, which is again is the crash jet top lid manufacturing, which is I told in 18 parts. It's also having a big challenge for such torus spherical shape to manufacture and control the tolerances. So it's also done with a full size mock-up of the complete top lid. You could see with the plate stage to the rolling, and then big flanges to be machined and welded. And finally, I'm happy to say that it is again good achievement from India within time, and all sectors are in advanced stage right now. 7 sectors are already packed and ready to ship, and today I think they will be put on the ship from the L&T Hazira. And you could see the fixtures, and again this was flag off ceremony held last month by DAE chairman and all distinguished participants from L&T and ITER India and ITER organization. So another major challenge to assemble these components, big components, and having a very critical tolerances and the requirements. So first stage to control the tolerances stage wise from factory to the sub-assembly, and then reach to the final stage. And we have to fit, and we have a lot of interface with the building on all components. So, and also big challenge is that we don't have a gap here. The building and crash jet is having only 500 mm gap. So we have to assemble with accuracy, and this is again a part of India to assemble and weld in the pit. So base section installation has been done successfully in May this year, and I could show the pictures. And again, it is not a just a picture, but we have to do a lot of exercise. The handling of a 1250 ton mass with the cranes. So you could see we are having a 4 cranes which are used to lift it, which are having a 375 ton load capacity on each. We have to do trial lifts for this to observe the deformations, to have a live metrology to position it perfectly. And later on, when we put on the pit, this is all optical metrology online being used. The crane was having a accuracy of a ±3. And to have a positioning on the pit, you could see the picture. This is a male and female lug. And we are having only 10 mm gap, 10 mm clearance for this. And this huge size of a 30 meter was aligned and fitted with the 20 mm clearance and successfully done with the toolings and all studies and as-built data study and development. So it was a great experience for us dealing on first of its kind component. And it is also a first component of heater machine which has been installed, major component in the pit. So major challenges for crash test manufacturing is controlling the stringent interface tolerances due to the distortion of high thick wets up to 200 mm. It took nearly 6 years for manufacturing and sub-assembly of base section, so you could understand the how much work is needed. Before that, it is around 2 to 3 years for the design and later on the manufacturing. And as I explained earlier, the radiographic testing was not permissible and have a problem if we can do, but the getting the RT permit and other issues is very difficult and it delays the schedule. So there is a good R&D exercise done by L&T for the UT weld characterization of the defects and everything. And this is only achieved with the close collaboration. And I think this is I would like to convey because normally we think the contractors are like we can do everything, we can scold them, but this is not the case for R&D. We have to work with the contractors like our partners, they are our collaborators, and with the good collaboration with ITER organization, ITER India, and also the L&T and their subcontractor MAN, we achieved the all requirements with quality, safety, and with all compliances. And also, I would like to convey that it is proud to be say that India has a capability to design, manufacture such heavy engineering components with precision and nuclear requirements. Thank you. So if you would like to ask questions on typical parameters,
Yes,
and
I think we will read out the question. I think in the box, I see one question there for you. Let me read it out and you can answer. This is a question from Kamal Talukdar. He wants to know what are the different applications of vacuum created by cryostat.
I think vacuum have a function like it will give the less thermal conductivity, and you are having a superconducting magnets in the heater machine. So to have a vacuum, you will reduce the thermal load on the superconducting magnets. So this is the function of the vacuum right now in this context of this machine.
Yeah, just to add to what Anil said, see the machine is in liquid helium temperature, 4K, and outside the cryostat, it's room temperature. And Therefore, if you want to have just one thermal shield, then the load is so high that you will need a huge liquid helium plant. To reduce that, you have an intermediate cooling, which is the liquid nitrogen. So you have a thermal shield with liquid nitrogen, and then you come out to the atmospheric temperature. Therefore, you reduce the load on all the components which are using the liquid helium. And therefore, the liquid helium plant, which is already probably the biggest in the world right now, what they are using, will become much bigger. So that's the reason why you need this huge cryostat, which creates the vacuum and gives a much less load, thermal load on the components, what Anil told basically.
Yes, thank you, sir.
Yeah, over to Chairman, sir. Chairman, Madam, please. She's not available. Thank you, Dr. Anil Bhardas, for your nice presentation about the detail about your project. And we all feel proud of your contribution to these international organizations. And thanks once again from all the participants and on behalf of the organizing committee. And now to proceed the program, the next presentation is the oral presentation. I think oral presentation number 10. Speaker is Mr. Vaibhav G. Go. Are you available?
Thank you all.
Mr. Vaibhav? Huh? Mr. Vaibhav? Huh? Will be presenting this Ms. Dipsika, are you presenting? So next speaker is Mr. Bapon Saha. Mr. Saha is available? Mr. Saha? Mr. Saha, are you available? Mr. Boy. Yeah, Ms. Dipsika, I think you can continue. Deepshika, please unmute your mic.
Okay, sir. Yeah.
So am I audible?
Yeah,
Okay.
please.
Good afternoon to everyone present for the conference. And I would like to thank the conference committee members for selecting me to present my topic here. So my topic is basically ultrasonication priming technology to modulate malting process in paddy. So first of all, I would like to give a brief idea what is the malting process actually in paddy. So malting, its first step is like germination. We go for some steeping process, then germination, and then we go for malting process. So what is steeping and what is germination and what is kindling process? I would just give a graphical abstract of that. So if we take a paddy, that is we soak it in some water, like in water for 24 hours to 48 hours.
Deepshika, please be loud.
Hello.
Yeah.
Yes, sir.
Please.
Okay, sir. So for the malting process, first step is steeping of the grain, whatever grain we are selected. So I have taken paddy, which is readily available in the northeast region or specifically in Assam. So what we have seen is that when we soak the paddy for 24 hours to 48 hours, that is called a steeping process in during germination. And then we go for germination of the paddy. And during the germination of the paddy, various biochemical changes occur. First of all, we can see that some phytohormones are stimulated, such as gibberellic acid, which then further stimulates other hormones such as alpha amylase, beta amylase, which passes from the alluron layer, from the scutellum rim to the alluron layer, and then to the endosperm. And the main component in paddy is the starch, which is drastically then broken down by these enzymes to various smaller molecules, as seen in, which can also be seen in my graphical abstract. That is, it may be glucose, maltose, or maltodextrins. They are broken down into smaller molecules for the embryo growth, and further malting takes place. So to give a hypothesis of my work and the previous literatures which I have taken. So we have seen the disadvantages of some traditional soaking, which we do in water, normal water, that is for 24 to 48 hours. We have seen that paddy grain has a very complex structure actually. So the husk, which acts as a main barrier for water absorption, and therefore the soaking has to be taken out for a long time. Like, as I said, it takes for around 24 to 48 hours. And during this time, actually various changes may occur, like microbial growth may also take place. And moreover, it is not like in industrial process, this is not very time efficient and energy efficient process. And moreover, during this process, also like due to the husk, also mass transfer process is also very slow. And therefore, we have gone for our we have thought of some emerging technology that can be applied for this germination process. So we have seen that some chemical process were already in use in industrial process or in the household processes, like some osmopriming, hydropriming techniques, or all these methods have been used previously also. But we have seen that these chemical methods can have some residue left during the germination process, and which can hamper when we intake that malted product, like in form of any other product, like this residues may be left out, and so it can be harmful for the health. So we have targeted some emerging process at low temperatures, and with a very short time of exposure, we can if we can initiate the germination process. So we have targeted for ultrasound, like some of the priming. First of all, I would like some of the to tell something about the priming technique. So what is basically a priming technique is the process of controlled hydration of seeds to a level that permits pre-germinative metabolic activity to proceed, but does not allow actual emergence of the radicle. So what are the different priming techniques? As I have talked in the other slide also, some of the common priming techniques which have been used industrially are hydropriming, that is in basically in water. Then there is halopriming in some chemicals, osmopriming techniques. Then hormonal priming is also used for faster germinations. Some of the novel technologies which we came forward were like ultrasonic processing, then high hydrostatic priming techniques, then cold plasma techniques. So we undertook this ultrasonic priming process for our advantage. And since we have seen due to the cavitation process of ultrasound, the porosity of the seed increases drastically. So the mass transfer process increases, and if the mass transfer process increases, the other biochemical process such as stimulation of gibberellic acid, mobilization of the nutrients to the cell membrane, which are in turn activates the enzymatic reaction, takes place very faster. So I would like to give a brief description of the my material method. So basically what I have done, I have taken two paddies. That is, one is Aizung rice, which is readily available in Assam, and one is the Chakhao variety of rice that is from Manipur, that is the black rice. So basically I have taken a non-pigmented rice and a pigmented rice. So I have given just approximate analysis of both the rice. That is the moisture content for both, which it was around 12%. Ash was around in the range of 1%. Fat was around in 2 to 6%. However, amylose we can see for the Chakhao rice, it falls in the category of Waxy rice, that is around 8.16. It has a very low amylose content. However, Aizung rice is in the higher amylose content or intermediate amylose content, that is 21, almost 22% amylose content. So for I have taken up a hydropriming process as a control, and then I have gone for ultrasound priming, and I wanted to compare both the method for effective germination process. So for the hydropriming process, I have taken 10 gram of precisely, and I have tied them into different net bags, and then I have soaked it in distilled water, and the water ratio was 1:3, and then I have germinated at different temperatures, that is 25, 30, 35, and 40 degrees Celsius, and then I have soaked it for 24 hours. And within this 24 hours, I have at every interval of 3 hours, I have taken the net bags. I have blotted with a blotting paper. I have wiped for superficially. I have wiped the moisture, and then I have taken the weight of this rice, and other process analysis were taken out, chemical analysis. Similarly, with the ultrasound priming also, we have seen that like 10 gram of paddy was taken, and it was placed in distilled water. And instead of normal hydropriming process, I have gone for ultrasound application. That is, I have given 10 minutes of pulse ultrasonication after every 1 hour, and it was given for and the process was taken for 12 hours compared to hydropriming, which we have done for 24 hours. And similarly, we have taken out the sample, and it was gone for we have done the chemical analysis. So first, basically, we have to see if the like priming, both the priming techniques, we have to see the malting potential, because it is ultimately is the end, the malting potential or the yield, whatever we get, that is mainly essential. So we have checked the germination rate, dormancy rate, and the germination capacity of the grain of the paddy for both the treatment. And then we have done some basic chemical and composition of malted rice, that is amylotic activity, total starch, and total reducing sugar. So if I go for the malting potential of the primed paddy, of the hydroprime paddy, we can see that at 25 degree and 40 degree, it was there was germination potential was low. However, at 30 and 35 degree centigrade, we can see a high amount of germination rate, and the dormancy rate has decreased significantly in both the temperature, and the germination capacity have increased very significantly. Same with the BR paddy, that is the black rice of Manipur. We can see that at 25 and 40 degrees centigrade, specifically in 40 degrees centigrade, the germination is very low, which might be due to the effect of temperature on the paddies during this hydropriming process. However, as the normal amylose Aizung rice, we can see that the germination rate was very high at 30 and 35 degrees centigrade. So significantly dormancy rate have decreased, and the germination capacity have also increased. Now, comparing this hydropriming techniques to the ultrapriming seeds, if we see the malting potential, we can see a very significant change. We can see that although at 25 and 40 degree, not much high germination was observed, but it was better than hydropriming. And at 30 and 35 degree, we can see almost 99% of the seeds have been germinated due to ultrasound priming. And to make a point here, the ultrasound priming, it was done for 24 hours. However, in 12 hours of ultrasound priming, we can see a very good germination rate at 30 and 35 degrees for both the paddies. So coming to the chemical analysis, if we the main two composition of starch is amylose and amylopectin, as we all know. So so first of all, I'm presenting the changes in the amylopectin, which is actually a very branch structure. So we can see that amylopectin have decreased significantly in hydropriming seeds, and it was further more the higher significant difference was observed in ultrasound primed, where a higher decrease in amylopectin was observed. And we can see this, as I have earlier also mentioned, this might be due to the various enzymatic activities which occur during the germination process, that there is very drastically change in amylopectin, there is breakage of the glycosidic bonds, and we can see that there is changes in the amylotic content for both the paddies. However, in ultrasound paddy, treated paddy, we can see higher drastic changes in decrease in amylotic content as compared to the hydroprime paddy. And if we see the statistical analysis, we can see the the interaction between treatment and the temperature and time. They had a very significant difference on this study actually for both hydroprimed and ultrasound primed treatment. So coming to the amylose content, as we can see, since there was, as we have seen a drastic change in amylopectin content, we can see a higher side of increasing trend increase in amylose content, which might be, again, as I said, which might be due to the action of various amylotic enzymes on the branch structure of amylopectin, leading to the formation of very small branch oligosaccharides, or to very small breakage of amylopectin into amylose content, which might have increased amylose content in both the paddy. And we can see the ultrasound priming at obviously at 12 hours, we have seen a very good result as compared to steeping for 24 hours, that is at the hydropriming condition. And if I go for the statistical analysis, again, we can see the temperature, treatment and time had a very good significant effect on the amylose content. For the amylotic activity, that is the enzyme activity which occurs during the process of germination, we can see that the maximum amylotic activity for NR was observed at 35 degrees centigrade. However, a higher activity for NR for that is Izung rice was observed as compared to the black rice for both the treatment at all temperatures actually. As mentioned earlier, since we have seen that amylotic activity was much higher in case of normal that is Izung rice, and therefore we can also say that amylopectin and amylose content have showed a significant difference for this Izung rice also. For the starch content, as I said, this is one of the most important component in the endosperm of a paddy. So we can see a drastic change in the starch content. For both the paddies, that is for the normal rice and the black non-pigmented and pigmented, that is the black rice also. During the priming condition, we have seen a degradation level of almost 33 and 38% in starch, were observed in terms of non-pigment, that is the Izung rice, when it was primed for 24 hours at 30 and 35 degrees centigrade. Similarly, in case of ultrasound also, but we have seen a higher change in the normal Izung rice as compared to the hydroprime paddy, which is mainly due, as I have mentioned, which might be due to the action of amylotic activity on the branch structure, that is the glycosidic linkages, which breaks down starch into smaller complexes such as glucose, maltose, or maltodextrin, which causes a drastic change in the starch content. And again, statistically, if I have to say, that is the treatment, temperature, and time was observed to have a significant difference on the starch content. The reducing sugar, as I have mentioned, that starch, it breaks down to some of the simpler complexes, that is the reducing sugar. So we can see those changes in terms of reducing sugar also. We can see it has exponentially increased up to almost 4 to 5 times it have increased in both the paddies. So we can say that and it was the reducing sugar in terms of ultrasound priming, it was much higher when compared to the hydropriming process. And we can see that the ultrasound priming had a very positive effect on the germination potential, on the all of the chemical changes. And as mentioned earlier also, we have done this ultrasonic priming in just 12 hours as compared to 24 hours of the hydropriming process. So if I go for the correlation matrix, that is for all the analysis that I have done, that is sugar, reducing sugar, starch, amylotic, amylose, and amylopectin, we can see that starch was having a positive correlation with this one. As alpha amylase have increased, the starch content have decreased, and similarly vice versa, all the correlation can be observed in this table. As I have mentioned, since as the enzyme increases, the starch content drastically starts to decrease. So this has been shown in this table. Then if I go for the SEM micrograph, which is very important to show that, to see the morphological changes of the whole paddy actually. So what I have done for this, I have taken a longitudinal section of the paddy after the germination, after the soaking of the paddy, and then I have subjected to SEM micrographs, and we have got this graphs, and we can see that after this is the native one, we can see it is quite smooth without any pins and holes, and the granules are without any rough surface. But when we go for hydropriming process, we can see some whole erosion has been observed in the granules. So we can see that the enzyme actions or the biochemical actions, that is mainly due to the hemolytic activity, some erosion has been occurred, and we can see that the enzymes might have created those holes through which the reaction starts to begin in both 30 and 35 degrees centigrade. Similar for ultrasound priming, we can see higher erosion and higher amount of, we can see like pins and holes are observed, which like, and the mechanism by which enzyme takes place is endocorrosion and exocorrosion. We can see an exocorrosion here in the SEM micrographs, where holes are created and through which enzymes can enter into the granules, and they can cause further reduction of degradation of the starch granules and convert it into sugar. So these are the pictures which I have taken, like this is the native black rice, and after hydropriming, this is the picture, and then ultrasound priming. Similar with the native normal rice, that is Aizung rice. Then after hydropriming and ultrasound priming, I have given the pictures of the germination done. So the conclusion, it's like at high germination capacity and rate was observed at for Aizung rice when compared to black rice, which might be due to the various physiological changes in the black rice. And we have seen that the time, temperature, and treatment had a significant effect on malting potential, specifically the hydropriming process. The enzyme activity, which mainly remains incipient in the native rice, which generally we do not observe in the native rice, those enzyme activity, but it was as germination process after during the steeping process, this we can see the enzyme activity increases. And we have seen that the enzyme activity of ultrasound prime paddy was significantly higher than the ultrasound, like the hydroprime paddy. And we have also seen the starch degradation was much higher in normal in Aizung rice as compared to the black rice. And the morphology also have seen this have shown some changes of the starch granules which was observed. So thank you. This is the conclusion.
Thanks for your nice presentations.
Thank you, sir.
And of course, there is no question in the question and answer box. So my colleague, Dr. Bharat, may ask one question, please.
Okay, sir.
Okay, so yeah, you have, it's a nice presentation.
Thank you,
so
sir.
You have measured the germination rate.
Yes, sir.
First, I
Yes,
want
sir.
to know how you have measured the germination rate.
Okay, so I'll just show you the formula. So this is the germination rate formula. So actually I have taken around 100 grains. So I have put it in a Petri plate in an incubator. Then after every 24 hours, I have checked how many grains have been germinated. And so I have taken out of like total number of viable grains which have germinated divided by the total number of grains, that is 100 into 100. So I have taken out a percentage of germination rate.
Okay. Okay. And you have mentioned about in your initial slides about the
Yes, sir.
three kind of different
Priming process?
Yeah,
Priming process?
ultrasonic priming,
Yes, sir. HPP process, yeah, priming.
priming, and cold
Yes, sir.
plasma priming.
Yes, sir.
So which is the best?
Sir, we have not tested all those things. I have just gone for ultrasonic priming, and in future I am trying for cold plasma priming also if possible, because cold plasma system is not available right now in IIT Guwahati. It's in Tezpur University. If possible, I'll surely try to do there. And high pressure processing also, it's like it's not in Assam now, it's in IIT Kharagpur. If possible, I'll surely try to merge all those studies and give a good result, sir.
Okay, yeah, I want to mention you that at ASCO, okay, we established a central research hub.
Yes, sir.
Okay.
Okay, sir.
And under that central research hub, we have a laboratory, metal, multidisciplinary experimental and testing accessible laboratory.
Okay, sir.
Okay.
Okay, sir.
And I am working there.
Okay, sir. Okay, sir.
In that laboratory already we have started some work.
Okay.
Use cold plasma technology for seed germination and for
Okay,
those
sir.
things.
It's
Okay.
very good. Okay, sir.
So,
Then.
but about this germination rate and those agricultural things, okay, since we don't have a much knowledge here.
Okay, sir. It's
I think it will be an opportunity for you and for us also. Okay,
sure,
do
sir.
some
Yes, sir.
collaboration, sir.
Sure, sir.
Okay,
Sure,
thank
sir.
you
Sure,
very
sure.
much.
Yeah.
Yeah.
Thank you, sir. Thank you,
Yeah.
sir.
Thank you, Ms. Kolida,
Thank you,
for
sir.
your nice presentations.
Thank you, sir.
And now next presentation will be by Mr. Saha. Dr. Bapan Saha. Dr. Bapan Saha is available? Please check once. Just confirm once whether he is available or not. And before that, we have some announcement. I request Dr. Bharat to announce all this important news.
Okay, it is an announcement to all participants, both oral and poster, and as well as the participant without any paper, that we will provide. It was because our one of the criteria that to get the participant certificate as well as oral and poster participation certificate, it is necessary to attend at least 80%. So those are the candidate or participant, those have a participation is more than 80%. We will provide them the certificate, hard copy. And for that, we need actually proper email address, proper corresponding address. So I request to all participants to send their correct corresponding address to send the hard copy of your participation certificate by post. Then next one is that since our poster presentation evaluation is going on right now, because we already means a expert committee, a review committee, they are evaluating all the posters to find out 20 best posters from each category, science as well as engineering and technology. So since there was a poster award, there is a poster award for each category. So tomorrow we will conduct a online poster presentation through Zoom portal only. Okay. So those are the shortlisted candidates. They have to present their posters through online. So we will circulate the Zoom link by today night to those shortlisted candidates. But all the candidates, those have already uploaded their posters, everybody will get paper presentation certificate. It's not depends on to get the presentation certificate. It is not necessary whether their poster is shortlisted or not. Thank you very much.
So next present is presentations from Dr. Bapan Saha from Henry Girls College, Guwahati. So this is over to you, Dr. Bapan Saha.
Is the screen available, sir?
Yeah, you're audible.
And the screen is available, sir, my laptop screen?
Yeah. Go to presentations mode.
Good afternoon, everyone. Today, I am going to present my paper entitled A DFT Study on Extended Undoped and De-Endoped Dibenzotriphenyline Reactivity Spectra and Band Gap Modulation. First of all, the introduction. Polyaromatic hydrocarbons have been extensively used in liquid crystal displays, organic dyes, batteries, organic electronics, photoresponsive materials, and many more. Boron and or nitrogen-doped polyaromatic hydrocarbons have gained much attention due to their wide optoelectronic applications. Moreover, molecules with twisted or skewed aromatic scaffold like helicins have also been useful in organic electronics, spintonics, chemosensor, and even in asymmetric catalysis. The optoelectronic properties of polyaromatic hydrocarbons can be tuned by introducing suitable substituents or side group, or even incorporating heteroatoms directly into the sp2 carbon skeleton. Now, compared to the triphenyline, its dibenzo analogs have drawn limited attention amongst the scientific community. This prompted us to scrutinize the properties of beyond of extended triphenylene derivatives. In our study, we performed the geometry study. We have studied the geometry of the system, what happens after the extension, then the molecular electrostatic potential surface, then variation in HOMO energy as well as shape of HOMO, then variation in global reactivity descriptor that gives the overall reactivity of the molecule, and variation in local reactivity descriptor that gives the reactivity of a particular site, then absorption spectra in gas and solvent phase, and then variation in band gap. For the purpose, we have performed computational studies, and for computational studies, we have used DFT, density functional theory has been used. Basically, what it does, it determines the molecular properties from electron density, and it is computationally affordable as well as produce reasonably good results, accurate results. For the purpose, we have made use of B3LOP, B3LOP 6311 plus GDP level of theory. We have made use of this level of theory for studying the purpose. And this level of theory has been used earlier also in literature for studying the molecular properties of the system. To ensure the real geometrical minimum of the studied complex systems, we have made frequency calculation, and the presence of positive frequency or non-negative frequency in our study confirm the existence of real minima for the studied structure. Then for the global reactivity descriptors, we have calculated the chemical hardness or global hardness, then chemical potential and electrophilicity. Global hardness is defined as difference between half of the difference between the LUMO and HOMO energy, whereas chemical potential is defined as the half of the average of LUMO and HOMO energy. And from chemical potential and global hardness, we can calculate the philicity or electrophilicity. Higher the value of chemical potential, higher the value of global hardness, higher is the stability. Lower the value of global chemical potential, higher is the stability, and higher the value of electrophilicity, lower is the stability. For local reactivity, we have made use of Fukui function calculation. Delta F is a dual Fukui function, which is basically the difference between the nucleophilic Fukui function and electrophilic Fukui function. If the Fukui function is positive, that is greater than 0, in this case, the site is susceptible for nucleophilic attack. Whereas if delta F is less than 0, the site is susceptible for the electrophilic attack. Now, sometimes what happens, this is calculated by using Koopman's theorem. But in Koopman's theorem, sometimes what happens, the LUMO, since LUMO is the virtual orbitals, there is no electrons at all at the LUMO. So determination of LUMO energy is sometimes questionable. So to assess our method, we have also used the delta SA method, according to which we have calculated the global hardness from valential ionization potential and valential electron affinity. Similarly, chemical potential from valential ionization potential and valential electron affinity, which is defined as follows. For UV visible spectra, we have made use of time-dependent density functional theory calculation. And for solvent phase studies, we have made use of PCM model. In PCM model, solvent is considered to be a dielectric continuum. And for overall calculation, we have made use of Gaussian 9 program package. Now, these are the optimized geometries. We have seen that since we have studied the extended triphenyl analogs, so first of all, we have studied the geometry of the triphenyl. It is found that geometry of the triphenyl molecule is absolutely planar. But on addition of this dibenzo group, dibenzo triphenyl, the geometry is non-planar. That means it is skewed, or you can say it is twisted. All the geometries are twisted depending upon their size. However, presence of dopant exert a nominal impact on their corresponding geometry. For that, we have measured the corresponding bond angles, dihedral angles. Upon dihedral angles, we have measured this carbon dihedral angle. This angle is found to be 152 degree, whereas in carbon boron nitrogen carbon bond angle or carbon nitrogen boron carbon bond angle, which is around 149 degree. That means there is not much difference of the corresponding molecular plane whenever if comparison made between the undoped system and the doped. However, geometrical change, variation in geometrical changes indicates that there will be definitely some reactivity parameter changes. Then molecular electrostatic potential surface. Molecular electrostatic potential surface is basically the electron distribution over the surface of a molecule or electron density distribution over the surface. And it has been used to predict the reactivity of a particular site as well as to study the reaction mechanism of the system. Since we are studying the reactivity, so we thought that yes, molecular electrostatic potential may be a suitable parameter by which we can gauge the reactivity of a particular system. It's seen that the triphenylene, the red colors are, wherever red colors are there, red colors are, means the electron rich region or a high electron density, and blue color represents the low electron density or electron deficient region, if you comparatively say this. In case of almost symmetrical, whereas upon extension or upon damping, there is significant difference in the distribution of electron density. That means the extension or presence of dopant has definitely some brought about some changes in the surface reactivity of the molecule. That may be suitable for the same kind of thing, or absorption or interaction with different molecules. Now, homo values and their shape. Homo value can also be used for predicting the stability of the system. Higher the homo value, higher means higher homo value means less negative, or lower homo means more negative. More negative homo value indicates stable system, and less negative homo value indicates more reactive system. Now, triphenylene moiety has the homo value around 142.98 kilocalorie per mole. Actually, I forgot the unit to mention. Whereas upon extension, we have seen that there is raise in homo energy level, irrespective of the dopant or irrespective of the size of the extension. Now, it can be concluded that upon extension, the reactivity of the system increases. However, if you compare the doped system and undoped system, the doped system has lower homo value than undoped system. That means compared to the undoped system, doped systems are less reactive as far as homo values are concerned. We have also studied the shapes of homo values. Shapes of homo values is important because homo is basically electron donating tendency, and where from the electron will move or where from the electron will not move, we can predict from the shape. It is seen that there is significant variations in the shape of the homo orbital. That means the electron donating site varies depending upon the size of the considered system as well as presence of dopant or position of the dopant. As a representative case, we have mentioned only this structure. However, this set we have not mentioned. Now, these are the global reactivity descriptors. It is seen that global reactivity descriptors, it is chemical hardness, it is chemical potential, and it is the electrophilicity. All the parameters, it is seen that chemical hardness decreases, then chemical potential increases, and electrophilicity increases down as we move, or as we extend the system, or as we move from smaller to the larger system. From this, we can conclude that, or as compared to the smaller system, larger systems are more reactive, irrespective of the nature and irrespective position of the dopant. This can also be concluded from the homo values. However, compared to the undoped system, corresponding doped systems are more stable. That means we have more global hardness parameters of this system. Similarly, same is the case in case of chemical potential as well as in case of electrophilicity. Now, we have also studied the local reactivity. Local reactivity descriptor, we have studied the carbon atom that is adjacent to the dopant, or the boron atom or the nitrogen atom. It is seen that in case of undoped system, the carbon atom has the Foucault function of minus 0.0018. Whereas in case of boron doped system, it is more negative. In case of nitrogen from this, it can be concluded that in case of boron doped system, the carbon that is adjacent to the boron is prone to electrophilic attack, whereas the carbon atom attached to the or adjacent to the nitrogen is prone to or susceptible to nucleophilic attack. Similarly, as expected, presence of dopant will induce some polar character in the molecule. It is also observed from the dipole moment values, and this polarity may be used for this sensor kind of activity as well as some absorption process. Now, this is a validation of MHP and MEP. Now, what is MHP? MHP is maximum hardness principle, and MEP is the minimum electrophilicity principle. According to maximum hardness principle, higher the hardness, higher ability, And minimum electrophilicity principle, lower the electrophilicity, higher is the stability. To validate these two principles, we have plotted the global hardness or chemical hardness versus electrophilicity, and it is seen that the system for which hardness is maximum, philicity is minimum. Thus, for most of the system, the MSP and MEP principle is valid. Now, to scrutinize the suitability of reactivity parameters determined from the Cookman's theorem, we have also used delta SCF method. And according to delta SCF method, we have calculated the ionization potential as well as chemical hardness and chemical potential. To compare the result, we have plotted the ionization potential obtained from delta SCF method and homovalence obtained from Cookman's method. And on comparison, it is found that there is a strong linear relationship between the two parameters. Similarly, in case of global hardness also determined from both the method, we have quite high, R square is 0.96. Similarly, for chemical potential, R square value is 0.92. That means we have a strong linear relationship between these parameters determined from the two methods. This validates that this theorem method, the reactivity parameters as we calculate from Cookman's theorem is suitable, and the reactivity pattern predicted from both the methods are similar. UV visible exhaustion spectra. It is seen that triphenylene has a strong peak around ultraviolet region. However, upon extension or doping, the peak shifted. It means shifted in the red shift. That means it is moving towards the visible region. That means if we extend beyond this, we can have extend beyond this, and for larger system, we can have the strong peak in the visible region. However, on studying the molecular orbitals that is responsible for the peak, we have found that these peaks are mainly attributed to the pi to pi star condition. And here is the molecular orbitals that are involved in the respective condition. And it is that as compared to the undoped system, the redshift obtained in case of both systems is less. This is the wavelength, excitation energy, oscillator stem, and the predominant orbitals involved in the condition process. Now, we have also scrutinized the effect of solvent phase on the UV visual spectra of the studied system. Here it is on the representative case, it is seen that there is not much shift. Not much shift. This shift is nominal below 10 nanometer. If we move the, study the absorption spectrum from gas phase to solvent phase, from cyclohexane, dichloroethane, sorry, it will be dichloroethane, DMSO, and water. Thus, presence of solvent phase exert nominal impact on the absorption spectra. Now, the band gap. We have calculated the band gap from the HOMO-LUMO gap as well as from the TD analysis. But researchers have made use of more use of HOMO-LUMO gap. That's why we have studied the band gap in this. According to the literature, the band gap below 4 can be considered to be a semiconducting property. Now, triphenylene, for triphenylene, we have band gap around 4.83 electron volt. Now, for all carbon analogs extended from, except this, one BN doped system, all others have band gap below 4 electron volt. That indicates that extension or presence of dopant or simply extension induces some semiconducting behavior on the studied. Now, although these values are almost higher, but these also predict similar trend, that means similar semiconducting behavior for the larger members. Now, to see wherever there is some relationship between the delta HOMO-LUMO gap obtained from the Cookman's theorem and from the time-dependent density functional theory, we have plotted the two parameters against each other, and it's found that R square value is around 0.85. That means we can say that there is some moderately strong relationship between the two parameters. However, the relationship is that we can claim that is both the parameters is exactly predicting the similar thing. The conclusion: extension and doping both affect the global and local reactivity parameters. Carbon atom adjacent to boron electrophilic and nucleophilic attack respectively. Redshift in absorption maxima is observed upon extension and doping. Extension lowers the band gap and thereby induces the semiconducting behavior. presence of solvent exert nominal impact on the electronic properties. Thus, the extended system might have possible optoelectronic application. However, experimental investigations are necessary to validate the fact, validate the point. Thank you.
Thank you, Dr. Bapun Saha. You have rightly maintained your time. In fact, this is the right time of your as per your schedule and for your nice
sir.
presentations.
Thank you, sir.
And in fact, what I see, your time was something like as per schedule. It was 55 and 2 to 3 minutes for discussion. So I think you are well in time. So I have not seen any question in the question and answer box, but certainly your presentation was nice. But of course, I am not an expert of your area, so I am not in position to ask a question also. Still, anybody have the question? I think they can raise their hand. We can see it if somebody have question. Yeah, one. Vijay Das, no? Could you please allow Vijay Das? I see. Anybody, please check one. No question. So, Dr. Saha, no question. Thanks for so much for the presentation, and we'll look forward in future also. We'll conduct this event every year. And tomorrow we have the session right at 10 o'clock in the morning. Yeah, 10 o'clock in the morning. This is technical session 5. And please join all the participants, in the morning session. And with these few words, and thanks to all the participants, panelists, and oral presenter, I conclude today's technical session, and we'll welcome you all tomorrow at 10 o'clock. Thank you.
Thank you all, sir.
And Srinivasulu, sir, thank you for
Thank you.
your
Yes,
so we'll hear it tomorrow.
Yeah. Afternoon.
Yeah. Thank you, sir.
Thank you.
Thank you, sir.